Imagine you are looking up at the night sky. Billions of stars scattered like dust, and yet every single one of them feels impossibly far away. Even the closest star, Proxima Centauri, would take us more than 4 years traveling at the speed of light to reach. Now think about that for a second. Light itself, the fastest thing we know in the universe, still needs years just to make it across our little cosmic neighborhood. So if aliens are real, if they are moving between stars, how on earth could they possibly be doing it? Before we continue, a quick note. Many of you watch our videos but haven't subscribed yet, so please subscribe to our channel Restwise and join our growing community. We'd also love to know where you're watching from and what time it is for you. It's amazing to see how connected we all are. If you enjoy relaxing with philosophy, psychology, and science while drifting into sleep, give this video a like and stay with us on the journey. Now, let's get back to the video. Here is where things get wild. The universe might already have a built-in highway system. Not spaceships crawling across empty space for thousands of years, but shortcuts stitched into the very fabric of reality. These are wormholes, and the idea of them is not science fiction fluff. Wormholes fall straight out of Einstein's equations. They are not just guesses. They are possible solutions to the mathematics of space-time itself. That means when Einstein gave us general relativity, he also gave us the blueprint for cosmic tunnels connecting two distant points in the universe. Now here is the part that feels almost unfair. If a wormhole exists, traveling across the galaxy becomes less like a marathon and more like stepping through a door. Imagine folding a piece of paper so two dots on opposite ends suddenly touch. A wormhole is basically the universe doing that fold for you. What would take thousands of lifetimes at even impossible speeds could, in theory, take seconds. That changes everything we think we know about alien travel. But here is the shocking twist. The math suggests wormholes are unstable. They collapse instantly unless something holds them open. So here is the burning question: could an advanced civilization, millions of years ahead of us, know how to stabilize them? Physicists have speculated that you might need something exotic, like negative energy, to keep a wormhole open. Negative energy sounds like fantasy, but we already know it can appear in certain quantum effects, like the Casimir effect, where empty space between two plates generates real measurable forces. It is tiny and fleeting, but it proves that strange forms of energy can exist. What if aliens learned to harness it? And here is where the validation kicks in. Think about the limits of our own progress. Less than 100 years ago, the idea of splitting an atom was pure science fiction. Now we not only split them, we harness nuclear power and even build quantum computers that play with the fabric of probability itself. If humans can leap from wooden planes to landing robots on Mars in a single century, what could a civilization with 1 million years of head start be capable of? The technology gap is so large that, to them, wormhole travel might not be magic at all. It could be routine infrastructure. We should also look at how nature itself seems to favor efficiency. Rivers carve the shortest paths to the sea. Trees distribute nutrients through branching networks that minimize wasted energy. Even our neurons connect through pathways that optimize signal speed. If evolution on Earth creates shortcuts everywhere we look, why would the universe itself be any different? Maybe wormholes are not rare cosmic glitches. Maybe they are natural pathways written into space-time, waiting to be discovered and stabilized. Aliens could simply be the first to figure out how to ride them, And there is another layer to this. Some researchers have suggested that black holes might actually hide entrances to wormholes, that the terrifying gravitational monsters we think of as dead ends could instead be gateways. If that is true, then the brightest civilizations might not fear black holes at all. They might map them, study them, and use them as stations on their interstellar highway. Imagine that. What we see as destructive voids could be signposts pointing the way across the galaxy. Now let us tease the implications. If aliens are moving through wormholes, then we need to rethink how we look for them. We spend billions building telescopes to scan for radio waves, assuming they talk like us across the slow crawl of light years. But what if they are not sending signals? What if they are stepping through shortcuts, bypassing the delay altogether? That would mean aliens could appear suddenly in regions of space without warning, then vanish just as fast. No long journeys. No waiting centuries for their message. Instant presence. That would also explain why our skies feel empty. We are listening for voices carried on the wind, when the real travelers are using highways we cannot yet see. It makes you wonder if the strange anomalies we do observe, sudden bursts of high energy, bizarre gravitational lensing, unexplained flickers in distant stars, are not just random noise. What if those are ripples from wormhole activity, like the wake of a ship passing unseen across the ocean? We dismiss these phenomena because they do not fit our categories. But maybe they are evidence that we are looking at traffic on the galactic freeway. Think about how that changes our sense of life itself. If wormholes are real and traversable, then the universe is not a cold, empty expanse. It is a connected system threaded with pathways. That means isolation is an illusion. Life could spread, civilizations could meet, ideas could flow. The barriers we assume, distance, time, isolation, suddenly collapse. And maybe that is the deepest reason to care about wormholes. It is not just about physics or aliens. It is about hope. Because right now humanity feels stuck, trapped on a fragile planet with limited resources. But if shortcuts exist, if the universe itself gives us ways to leap across the stars, then our future is not bound to this rock. It is open, vast, and full of possibility. Entanglement as communication faster than light. Picture this. Two particles born together in the same instant, like twins. You separate them by a mile, by 100 miles, by 1 billion light years, and yet they remain connected. Change something about one, and instantly, without delay, the other reflects that change. Not seconds later, not traveling through space, but right now. No signal crossing the gap. No waiting. Just instant connection. That is quantum entanglement. And if you are not a little freaked out, you should be. Because this is not speculation. This is not science fiction. It has been proven in laboratories over and over. Particles can be entangled. The universe allows them to share a hidden link that is beyond the limits of space and time. Einstein himself hated this idea. He called it spooky action at a distance because it seemed to break his most sacred principle, that nothing can travel faster than light. Yet experiment after experiment shows it is real. Now imagine what that means for communication. Right now, if we wanted to talk to Mars, even at light speed, there would be a lag of minutes. If we wanted to send a message to another star, we would be waiting years for a reply. Interstellar communication under the rules we know today is painfully slow. But what if aliens are not playing by our rules? What if they have cracked the code of entanglement and turned it into a communication system that is truly instant? No delay. No distance. the same conversation across the galaxy as easily as across a room. Here is where the shock sets in. Physicists will tell you that entanglement cannot be used to transmit information in the way we normally think. That measuring one particle tells you nothing useful without comparing it to the other, and that comparison still requires a regular signal moving at light speed. That is the standard view. But let us pause and ask, are we really so sure? Because humans once said heavier than air flight was impossible. Humans once said the atom was indivisible. We are still infants when it comes to quantum mechanics. Every year it reveals new surprises. The fact that we cannot imagine how entanglement could carry information does not mean a more advanced civilization has not already solved it. Think about how technology evolves. Morse code seemed miraculous when it first appeared. Then came telephones, then satellites, now video calls spanning continents in seconds. To someone in the 1800s, what we do every day would look like magic. So why should it be unthinkable that aliens might use the deepest strangeness of physics itself as their communication backbone? And there is validation here if you look closely at the direction of our own research. Scientists are already exploring entangled photons to create unbreakable encryption. Quantum key distribution is not theory anymore. It has been tested in real world conditions, even between satellites and ground stations. That means we are already bending entanglement into practical use. If humans can do that with our baby step technology, how much further could a civilization with thousands or millions of years of head start push it? Now let us step into the bigger picture. Imagine a civilization spanning multiple star systems. If they relied on light, speed communication, their empire would move slower than molasses. Orders sent from one system to another would take decades to arrive. Coordination would be impossible. But with instant, entangled communication, the whole civilization could act as one mind, decisions shared across light years instantly, cultures remaining unified despite distance. To us it feels impossible, but to them it would be the only way to function. And maybe this is why we have not found the signals we expect. We keep listening for alien radio waves, assuming they will shout across the stars like we would. But what if they abandoned radio ages ago? What if they skipped right past it into a communication method that leaves no trace for us to hear? Entanglement would be silent. No leaks into the cosmos. No detectable chatter. From our perspective, the galaxy would be dead quiet, while in reality it could be buzzing with instant conversation that we simply cannot intercept. Think about how frustrating that is. We build massive dishes, spend billions searching for patterns in the noise of the universe. And maybe the truth is that the real communication network is invisible to us. Like ants crawling near a Wi-Fi router, unable to sense the flood of information blasting past them. And here is the tease. If entanglement is the key, then unlocking it is not just about science. It is about survival, because whoever controls instant communication controls connection itself. Imagine the power of coordinating ships, colonies, and even artificial intelligences spread across the stars without delay. Imagine no distance being too great for ideas to flow. And imagine how isolating it would be for a young species like ours, locked in slow light speed communication, while older civilizations talk effortlessly across the galaxy. That possibility should make us curious, maybe even a little desperate, because what we call impossible today may simply be a door we have not yet learned to open. And behind that door might be the greatest conversation in the history of life. Alien approaches to gravity manipulation. Think about what it feels like to fight gravity every single day. Airplanes burn oceans of fuel just to lift a few hundred people into the sky. Rockets spend 90% of their mass on fuel just to break free of Earth for a few minutes. Gravity is the cage that keeps us grounded, the invisible chain around every species that evolves on a planet. Now picture what happens if someone learns to bend that chain. Not fight it with brute force, not escape it with explosions, but actually manipulate gravity itself. That is not just a leap in technology. That is a rewrite of civilization. Here is the shocking part. We treat gravity like this untouchable constant, but it is not untouchable at all. Einstein showed us that gravity is not a force in the way we once thought. It is the bending of spacetime itself. Mass and energy tell space how to curve, and space tells matter how to move. That means gravity is not some magical force you can never touch. It is a shape. And if something can reshape spacetime, then gravity is just clay waiting for the right hands. Imagine what aliens could do with that. No more rockets clawing their way into orbit. Ships lifting off silently, effortlessly, like leaves rising in the breeze. Entire cities hovering above ground with no need for support beams. Travel across planets without wheels, without fuel, without drag. A society built not around overcoming gravity, but around sculpting it like art. Now here is where your stomach drops. We already see hints that gravity can be manipulated, but we do not understand how. Scientists know that extreme masses like black holes warp spacetime so much they trap even light. We know gravitational waves ripple through the universe, carrying energy across billions of light years. We can measure those waves with instruments so precise they detect distortions smaller than a proton. That proves gravity is dynamic. It can be bent. It can be moved. It is not locked. If we, with our crude tools, can measure its ripples, what might an advanced civilization be doing with it? There is also the strange fact that gravity is the weakest of all the fundamental forces. Electromagnetism is stronger by factors of trillions. Nuclear forces are unimaginably more powerful. So why is gravity, the one force that shapes entire galaxies, so faint on the small scale? Physicists call this the hierarchy problem. Some suggest gravity might actually leak into dimensions we cannot see, and that is why it feels so weak. If that is true, then maybe aliens discovered how to reach into those hidden dimensions and pull on gravity directly. And here is the validation point. Look at our own behavior. We barely understand magnetism a few hundred years ago, yet today we levitate trains using magnetic fields. We once thought heavier, then air flight was absurd, now we fill the skies. If we are already experimenting with things like the Alcubierre drive, which is literally a proposal to bend spacetime with negative energy, then what would aliens a million years older be doing? Manipulating gravity could be their most basic technology, as simple to them as a wheel is to us. Now let us tease out the implications. If you can control gravity, you can control time. That is not speculation. General relativity tells us time runs slower in stronger gravitational fields. That is why clocks on GPS satellites tick differently than clocks on Earth. The effect is tiny, but it is real. Manipulating gravity is manipulating time itself. That means aliens with gravity technology would not just travel across space differently. They would experience time differently. Journeys for them might take hours while centuries pass outside. They would hold the keys not just to the cosmos, but to the flow of history. And maybe, just maybe, we have already brushed up against evidence of this. Reports of unidentified craft that seem to defy inertia, moving at impossible speeds. making sharp turns without crushing their occupants? What if those are not breaking the rules? What if they are bending the rules we do not yet know how to touch? If gravity is being locally reshaped, then acceleration does not feel like acceleration. The ship and everything inside it rides the curve of space, untouched by the brutal forces that should rip it apart. This is where curiosity takes over, because once you accept that gravity is not untouchable, you start asking bigger questions. Could entire planets be engineered with altered gravity, tailored for the species that live on them? Could stars be nudged slightly to extend their lifespans, giving civilizations more time to thrive? Could artificial black holes be stabilized and used as power sources? When you stop seeing gravity as a cage and start seeing it as a tool, the scope of what becomes possible is staggering. And here is the final tease. If aliens have mastered gravity, then the very idea of space travel changes. No more fuel. No more distance as an obstacle. They could launch entire fleets effortlessly. They could hide in warped regions of space-time, invisible to our telescopes. They could appear and disappear like ghosts, not because they are magical, but because they learned to ride the curves of reality itself. That thought should not just make us wonder about them. It should make us wonder about us. Because if the universe allows gravity to be shaped, then one day we might learn to shape it too. And when we do, our definition of being human will not survive unchanged. We will step into a universe where gravity is not a limit, but a canvas. 0-point energy fact, fiction, or alien reality. Picture this for a moment. You are sitting in the quietest room imaginable, no light, no sound, nothing moving. You might think you have reached true emptiness, but physics says you would be wrong. Even in perfect vacuum, stripped of matter, stripped of heat, stripped of all energy we can imagine, there is still something left. A restless jittering at the foundation of reality itself. That is 0-point energy, the lowest possible energy that a quantum system can have. In other words, even nothing is not really nothing. Now here comes the shock. The numbers behind 0-point energy are mind-bending. If you calculate the raw energy density of empty space using quantum mechanics, the result is so massive it could boil entire oceans with the power locked inside a single teacup of vacuum. That sounds insane, impossible, like a cosmic exaggeration. But the math is there. The only reason our universe is not exploding with this energy is that most of it cancels out or hides in ways we do not yet understand. So the question is simple but terrifying. What if an advanced civilization figured out how to tap into it? What if aliens already know how to harvest the restless hum of empty space? Because if that is true, then energy scarcity, the thing that defines every struggle on our planet, simply disappears for them. Imagine societies where power is infinite, where machines run forever without fuel, where starships glide silently powered by the vacuum itself. That is not just progress, that is transcendence. And here is where we have to validate the idea. 0-point energy is not just some fantasy made up by conspiracy theorists. It is woven into real physics. The Casimir effect, discovered in 1948, shows two metal plates placed close together will attract each other because of changes in the quantum vacuum between them. That attraction is not caused by any visible force. It is the direct effect of 0-point fluctuations. We can measure it. We can predict it. It is tiny, yes, but it is real. So if even we, with our clumsy instruments, can touch the edge of it, who is to say a civilization millions of years older could not open the floodgates? Think about what humans do when we find just the tiniest crack in nature. The first person to notice static electricity could never have imagined cities lit by power grids. The first person to play with magnets could never have imagined levitating trains. We have a pattern of taking the smallest hints and turning them into revolutions. So if aliens have had centuries, millennia, or even millions of years to study quantum fluctuations, zero-point energy might not be a mystery to them at all. It might be the backbone of their entire society. And here is a darker layer. If zero-point energy is real and usable, then it is not just free energy. It is ultimate energy. Weapons built on it could dwarf anything we can imagine. Stars themselves could be manipulated. Planets could be cracked like eggs. It is power on a scale that makes nuclear weapons look like firecrackers. That possibility makes the silence of the cosmos feel heavier, because maybe civilizations that discover how to tap the vacuum either ascend into godlike longevity or destroy themselves almost instantly. Now let us tease this out further. If aliens are using zero-point energy, then maybe we have already seen the fingerprints of it without realizing. Reports of unidentified craft accelerating without any visible exhaust, glowing with strange energy fields, moving in ways that defy conventional propulsion. Those behaviors line up with a power source that does not rely on chemical fuel. It does not even rely on nuclear fuel. It taps into something deeper, something hidden. And if that is true, then the mystery is not just what powers them, but how they have learned to control it safely. Because here is the catch. If you mess with zero-point energy without mastery, you risk tearing at the vacuum itself. You risk opening doors you cannot close. Our scientists worry that trying to manipulate it on a large scale could destabilize the balance of space. To aliens, though, that danger may be long behind them, solved like we solved the dangers of fire or electricity. For them, zero-point mastery could be the first step in becoming a true spacefaring species. Now think about what that means for us. Every conflict we face today, wars over oil, over territory, over limited resources, vanishes the moment unlimited clean energy becomes possible. The poverty, the inequality, the endless fight over scarcity, all of it dissolves. But here is the irony. We crave that solution, but maybe we are not ready for it. Because infinite energy in the hands of an immature species is not liberation. It is chaos. It is handing a toddler a flamethrower. That might explain why we do not see civilizations shouting across the stars. Maybe the price of mastering zero-point energy is either learning restraint or vanishing from the stage of history, and that leaves us with the tease. Is zero-point energy fact, fiction, or alien reality? The answer might be all three at once. It is fact in the sense that we know the vacuum is not empty. It is fiction in the sense that we have no way to harness it with our current technology. And it might already be alien reality if others have solved what we have barely begun to ask. If so, then the future of life in the universe is not bound by scarcity. It is bound only by imagination, and by whether a species can wield infinite power without destroying itself. Exotic matter, negative mass and its implications. Try to picture this in your head. You give something a push, and instead of moving away, it races back toward you. You drop it, and instead of falling down, it falls up. That is what negative mass would mean. A form of matter so strange that it does the exact opposite of everything your intuition screams should happen. And here is the kicker. The equations of physics do not forbid it. They whisper that under the right conditions, it could exist. Now the shock. Negative mass is not just a quirky thought experiment. If it exists, it changes the rules of the universe. Ordinary mass resists acceleration, that is inertia. Push a car, and it takes energy to get it moving. But negative mass would flip inertia on its head, push it, and it accelerates in the opposite direction, gaining energy from the push. That means, in theory, if you put positive mass next to negative mass, you could create propulsion without fuel. A spaceship could accelerate forever, drawing motion out of the tension between opposites. It sounds like a cheat code for the laws of physics, but it emerges naturally from the math. Here is where we need to validate the strangeness. Scientists have already played with hints of negative mass behavior. In 2017, researchers at Washington State University cooled rubidium atoms to near absolute zero, creating what is called a Bose-Einstein condensate. Under specific conditions, the atoms acted as if they had negative mass. When pushed, they moved backward. This was not pure science fiction. It was an experiment showing that exotic matter can be engineered in a lab, at least in small, fragile forms. That does not mean we have true negative mass in buckets, waiting to be used. But it proves the universe allows matter to behave in ways we once thought impossible. Now let us step back. Why would aliens care about negative mass? Because negative mass could be the missing ingredient in technologies we dream about but cannot build. Wormholes, for example. The math says they collapse unless something exotic holds them open. Negative mass, with its repulsive gravitational effects, could do exactly that. Imagine an alien civilization threading wormholes across space, stabilizing them not with endless energy, but with reservoirs of exotic matter that keep the tunnels open. To us, wormholes are fragile dreams. To them, they might be infrastructure, like roads or bridges. And think about warp drives. The famous Alcubierre drive proposed in 1990 is a solution to Einstein's equations that allows faster than light travel. But there is a catch. It requires negative energy or negative mass to expand and contract space-time around a ship. Without exotic matter, the drive is pure fantasy. With exotic matter, it becomes possible. If aliens can engineer or harvest negative mass, they are not bound to crawl across the galaxy. They can ride waves of warped space-time. This is where the validation deepens. Humans always dismiss what we cannot yet control. Electricity was once lightning in the sky, terrifying and divine. Now it is the lifeblood of our civilization. Radioactivity was once invisible death. Now it powers cities and treats cancer. Exotic matter may sound like science fiction, but so did every revolutionary force before it became practical. And we are already dipping our toes into the pool, creating negative mass like behavior in ultra-cold experiments. That is the faintest echo of what a civilization millions of years older could achieve. Now let us tease the implications. If aliens use negative mass, then entire regions of the galaxy could be reshaped. Exotic matter would repel ordinary matter gravitationally, meaning they could carve out voids in space, hollow regions where gravity behaves differently. Planets could be stabilized against collapse. Stars could be manipulated, even extended, by balancing their internal pressure with negative mass scaffolds. Civilizations could literally sculpt the cosmos. But there is also the darker side. Negative mass interacting with positive mass could create runaway motion, an engine that accelerates endlessly. That might sound like free energy, but it also means instability. If not controlled, a tiny imbalance could release catastrophic forces. Maybe that is why we do not see civilizations broadcasting proudly across the galaxy. Maybe some of them reached the stage of exotic matter and vanished, consumed by technologies they could not fully contain. And here is the personal layer. Imagine what it would mean for us, for humanity, if we ever learned to harness exotic matter. War over oil, over coal, over resources would suddenly feel primitive. We would not need to strip planets bare for energy. We would not need rockets bursting with fuel to reach the stars. We could unlock travel, stability, even immortality for our species. But at the same time, we would be holding the most volatile key in existence, the key to bending space-time itself. So the question lingers. If negative mass is possible, is it a gift the universe left us, or a trap waiting to destroy anyone reckless enough to grab it? For aliens, it might already be reality. For us, it is still a whisper at the edge of physics, a dangerous promise shimmering in the math. And whether it becomes our greatest triumph or our undoing depends entirely on whether we can grow wiser before we grow more powerful. Photonic life forms bodies made of light. Close your eyes for a second and imagine life without flesh, without bone, without any physical matter at all. Imagine beings not bound to planets, not trapped by gravity, but existing purely as patterns of light. No hunger, no decay, no death in the way we understand it, just radiant forms that move at the speed of light, woven out of photons, the very particles that carry energy across the universe. Sounds impossible, right? But what if it is not? What if the future of life is not flesh and blood at all, but luminous intelligence born from light itself? Here is the part that knocks you off balance. Photons, by their nature, never age. They travel at light speed, and from their perspective, time simply does not pass. A photon created at the birth of the universe is, in a sense, the same photon now striking your eye. So if consciousness could ever be built on photons, it would not just be alive, it would be timeless. That changes everything we think we know about life and survival. A photonic being would not fear mortality the way we do. It would exist as long as the universe allows light to exist. Now let us ground this in validation. We already see life finding bizarre forms here on Earth. Bacteria that eat radiation, creatures that thrive in boiling vents at the bottom of the ocean, organisms that survive frozen in space. Nature constantly proves that life adapts to whatever substrate it can. So why should carbon-based biology be the only option? If intelligence is just the arrangement of information, then there is no reason it could not one day migrate from cells to silicon, from silicon to photons. In fact, we are already inching in that direction. Scientists are building photonic chips that use light, not electricity, to process information faster and with less energy. In other words, we are teaching light to think, and if we are stumbling toward this future, imagine what aliens a million years older might have achieved. Perhaps they shed their physical bodies long ago, evolving or engineering themselves into pure photonic structures, beings that live in plasma fields around stars, feeding on stellar radiation, civilizations drifting through galaxies as radiant networks, invisible to us unless we know how to look. They would not leave ruins or machines we could easily recognize. Their existence would be written in light, subtle and dazzling at the same time. Here is where it gets eerie. What if some of the strange cosmic phenomena we observe, the sudden pulses of gamma rays, the mysterious flashes of light from distant galaxies, the repeating fast radio bursts, are not just natural events, but signatures of photonic life communicating or moving in ways we cannot decode? We dismiss them as noise, because they do not fit into our categories of biology. But maybe that is our mistake. We are looking for flesh and bone, when life may have already transcended matter. And think about the implications of a being made of light. Travel becomes effortless. No need for ships, no need for fuel. They ride beams of starlight, slipstreaming across interstellar distances at the maximum speed the universe allows. To us, crossing even the nearest star system is an impossible journey. To them, it is just the rhythm of existence. They would not colonize planets the way we imagine. They would inhabit energy fields, clouds of plasma, even the radiation belts around stars. Their homes would be light itself. But here is the deeper validation. Physics already shows us that information can be stored and carried in photons. That is how fiber optics work. We stream movies, messages, entire libraries across the world using pulses of light. If human culture already lives partially in photons, our knowledge, our voices, our art, then the leap to photonic life is not as far as it sounds. We have already taken the first steps, even if we do not yet realize it. And now the tease. What happens when matter-based life like us encounters photonic life? Would we even recognize them? They might appear as glowing entities, as angels in our myths, as strange orbs of light people swear they have seen in the skies. To them, we might look unbearably slow, weighed down by matter, by decay, by the ticking clock of time. If they exist, they are already beyond hunger, beyond war, beyond scarcity. Their challenges would be different. Perhaps coherence, stability, communication at the edge of light speed. But here is the haunting possibility. Maybe the universe is full of life, yet we fail to see it because we expect it to look like us. We scan for planets with oxygen atmospheres, for biology like ours, when life may already shimmer all around us, not as matter but as light. And if that is true, then the question is not whether photonic life exists. The question is whether we are ready to perceive it. Because if the future of intelligence is to migrate into light, then we are staring at our own destiny. One day, humanity might not be flesh at all. We might become radiant, immortal patterns, thinking beings traveling as photons through the cosmos. The end of the human story may not be extinction, but transformation. And maybe, just maybe, when we finally learn to listen with the right eyes, we will find that those luminous civilizations have been waiting for us all along. Could alien physics explain UFO phenomena? For decades, people have looked to the sky and seen things that should not be there. Objects darting faster than any known aircraft, hovering without wings, shifting direction without inertia, glowing with strange auras, and vanishing in an instant. The reports come from pilots, radar operators, even astronauts, and the pattern is always the same: technology that looks far beyond us. The natural question is simple. If these sightings are real, what physics could possibly explain them? Here is where the shock hits. Most UFO accounts describe movements that break our current understanding of physics. Sharp turns that should crush a pilot with G-forces, yet the craft seem unaffected. Accelerations so sudden they would require engines more powerful than anything we can imagine. Yet there is no roar, no exhaust, no heat trail. Objects vanishing without sound, as if they slipped out of reality itself. If these are just human inventions, then we are hiding miracles in plain sight. But if they are not, then maybe the explanation lies in physics we have not mastered yet. Physics that aliens may already wield with ease. Let us validate that idea. Think about the subtopics we have already explored. Wormholes could explain sudden appearances and vanishings, shortcuts in space-time that make a craft flicker in and out of sight. Gravity manipulation could explain silent hovering and effortless acceleration, bending spacetime so that motion feels smooth and inertia disappears. Exotic matter could fuel propulsion systems that look like magic to us. Zero-point energy could power ships without the telltale burn of fuel. These are not disconnected theories. They all form a framework that matches the bizarre behaviors people describe. Even our own experiments hint at pieces of this. General relativity shows us that gravity bends light. Quantum physics shows us that energy exists even in the vacuum of space. Laboratory work with negative, mass-like states proves that matter can move in counterintuitive ways. We already know the rules of physics are far stranger than common sense allows. So why is it so unbelievable that someone else might already be using those rules in ways we cannot yet replicate? And think about how humans once described new technology. Ancient people who saw solar eclipses thought gods were eating the sun. Explorers who sailed into unknown lands described beasts that sounded mythical until science explained them. Even in modern times, radar operators in World War II reported strange lights and maneuvers that turned out to be early jet aircraft. History is filled with moments where something looked supernatural simply because the observers lacked the framework to understand it. Maybe UFOs are another example. Not magic, not fantasy, just physics that sits ahead of our learning curve. Now here is a deeper layer. If UFOs are alien technology, they might not even be designed for us to perceive. Imagine trying to understand a smartphone if you lived in the Stone Age. You might see flashes of light, hear strange sounds, maybe even feel heat, but you would have no clue what the device was doing. To us, a UFO might look like a glowing sphere or a dart of light, but to them, it could be a complex machine operating in dimensions we cannot even detect. What we call unidentified may simply be misunderstood. And here is the tease. If alien physics explains UFO phenomena, then our skies are not just empty stretches of atmosphere. They are crossroads. The real question is not whether something is out there. The question is whether we are ready to admit that the laws of the universe might already be on display above us. UFOs may not be a puzzle to solve in isolation. They may be the most visible clue that the physics we dream about, wormholes, exotic matter, gravity manipulation, is already being used. And if that is true, then we are not just looking at unexplained lights. We are looking at the future of our own species, flying right past us. Propulsion without rockets, field drives. Every time we launch something into space, it feels like a struggle. A roaring column of fire, thousands of tons of fuel, an explosion controlled just enough to push a fragile payload out of Earth's grip. Rockets work, but they are messy, dangerous, and ridiculously inefficient. They waste nearly everything just to escape gravity's hold. If this is the best we can do, then how could anyone, alien or otherwise, travel the stars? Here is the shock. Rockets might be nothing more than training wheels. Primitive, loud, obsolete the moment you discover something far more elegant: propulsion without propellant. Field drives. Instead of carrying fuel and blasting it out the back, a field drive manipulates the fabric of space-time itself. Imagine a ship wrapped in a bubble that shifts the space around it rather than pushing against it. No exhaust, no roar, no limits of fuel. Just smooth, silent motion. This is not pure fantasy. The math allows for it. The Alcubierre drive, first proposed in the 1990s, showed that space-time could theoretically be compressed in front of a craft and expanded behind it. The ship itself does not move through space in the usual sense. It rides a distortion of space. That means no speed limits from relativity. The ship never breaks light speed locally, but the bubble of space it rides can move faster than light relative to everything outside. That is not fiction. That is Einstein's equations turned into possibility. And here is where it gets validating. Even in our own crude labs, we are already testing pieces of the puzzle. Scientists play with electromagnetic fields, with plasma, with superconductors, trying to see if thrust can be generated without fuel. Most results are tiny, controversial, sometimes even dismissed. But history is full of breakthroughs that started as anomalies. When Heinrich Hertz first produced radio waves, people said they were useless. When the Wright brothers first flew, the newspapers barely noticed. Small, confusing results often come before revolutions. Aliens, with a million-year head start, could have perfected what we only toy with. Imagine ships that bend gravity fields, that surf the vacuum energy, that glide silently without engines in any conventional sense. That would explain why UFOs appear to move without visible propulsion, why they accelerate without the thunder of rockets. They are not burning fuel. They are moving fields. Now consider what field drives would mean for society. Rockets make every trip expensive. Every launch burns mountains of resources. A field drive would make motion cheap, effortless. Entire civilizations could travel not just across planets but across stars without worrying about fuel reserves. Colonies could bloom like seeds scattered in the wind, not constrained by the tyranny of chemistry. Transportation becomes as natural as breathing. There is also the psychological shock. We tend to imagine technology evolving gradually. Faster cars, stronger rockets, better planes. But a field drive would not be a step forward. It would be a rupture. It would make every previous method look like cave paintings. A civilization with field drives would not just be more advanced than us. They would be operating on a different level of physics altogether. Here is the tease. What if some of the strange phenomena we observe in space, mysterious bursts of energy, odd lensing effects, unexplained accelerations of certain objects, are not natural at all? What if they are footprints of field drives, ripples left behind by civilizations moving in ways we do not yet understand? To us, they look like anomalies. To them, they are just traffic. And think about what this means for our future. If we unlock field drives, we will not just expand outward. We will redefine what travel even means. No more borders locked by oceans, no more planets isolated by light years. Humanity would step into a universe where distance is no longer a prison, and maybe that is the ultimate truth hidden in the skies. That rockets are not the destiny of space travel. They are just the beginning. The real story starts the moment we stop burning fuel and start bending fields. Quantum consciousness, alien minds, and physics. Think about the strange, slippery thing we call consciousness. That voice in your head, the awareness that you exist, the ability to imagine, to wonder, to dream. We still do not know where it really comes from. Neuroscience can map neurons firing, can trace chemical signals, but the spark itself, the feeling of being alive inside your own head, remains a mystery. Now imagine if the answer is not just biology, but physics. Imagine if consciousness is not just neurons talking to each other, but quantum processes happening deep inside the brain. Here is where the shock comes in. If the mind is quantum, then it is not bound by the rules of classical machines. Quantum systems can exist in superpositions, multiple states at once. They can be entangled, instantly linked across distance. They can tunnel through barriers that should be impossible to cross. If consciousness taps into this, then alien minds might not think the way we do at all. Their awareness could be spread across space, entangled with other minds, operating on layers of probability instead of simple yes or no logic. They would not just be smarter. They would be thinking in dimensions we cannot yet grasp. And here is the validation. This idea is not pulled from thin air. Some researchers, like Roger Penrose and Stuart Hameroff, have proposed that microtubules inside neurons might host quantum effects that give rise to consciousness. The theory is controversial, but it points to a real puzzle. The human brain is staggeringly efficient, far beyond what our best computers can do in terms of energy use. Something unusual may be happening under the hood, and quantum mechanics is a candidate. We already know photosynthesis uses quantum coherence to move energy with near-perfect efficiency. Birds may use quantum entanglement in their eyes to navigate Earth's magnetic field. If evolution taps into quantum mechanics for plants and birds, why not for minds? Now imagine aliens who have not just stumbled into this by accident, but mastered it deliberately. Their brains, or whatever organs they use to think, might be engineered quantum processors. Every thought would be more like a quantum computation, exploring countless possibilities at once, collapsing instantly into insight. Where we struggle to imagine 10 outcomes, they might hold thousands in mind simultaneously. Where we debate, they could entangle their awareness with others, merging perspectives instantly. Communication between them might not even require words. It could be shared consciousness, spread through physics itself, and this changes the entire concept of what it means to meet them. We look for signals, radio waves, mathematical patterns, because that is how we communicate. But if they use quantum consciousness, they might reach us in ways we do not yet recognize. A sudden intuition, a dream that feels alien, a synchronicity that seems too perfect. To them, these would not be strange. They would just be communication on a channel we have not yet tuned into. Here is another layer. If consciousness is quantum, then it may not be confined to a brain at all. It may be something the universe itself allows, like gravity, like electromagnetism. In that case, alien minds may not even need bodies. They could exist as patterns in quantum fields able to shift, merge, separate, spread across distances. The boundary between self and other, between individual and group, would blur. A civilization like that would not be built of separate beings. It would be a shared quantum awareness, countless minds thinking together as one. Now let us tease the implications for us. If aliens live in quantum consciousness, then their view of life and death is nothing like ours. We see death as an ending, but they might see it as decoherence, the dissolving of one pattern back into the universal field. To them, the individual does not vanish. It blends back into the whole, like a wave collapsing into the ocean. That means their culture, their philosophy, even their morality would be shaped by physics in ways we can barely imagine. And here is the eerie possibility. Maybe we already brush against this. Moments of intuition we cannot explain, flashes of connection with others we feel instantly. Experiences of transcendence reported in meditation or under altered states. Maybe these are glimpses of quantum processes in our own minds. Rare, fragile, easily drowned out by noise, but real. If so, then the step from human to alien consciousness is not infinite. It is already inside us, waiting to be amplified. So the real question becomes, are we willing to see consciousness not just as a biological accident, but as a physical phenomenon woven into the universe? Because if we are, then alien minds stop being unimaginable. They become inevitable. And one day, when we finally meet them, it may not be with words or mathematics. It may be with a direct merging of awareness, a joining of minds across the quantum fabric of reality. And that would not just change how we see aliens. It would change how we see ourselves. Extra dimensions, a multiverse of possibilities. When you look around, the world feels three-dimensional. Forward and back, left and right, up and down. Add time as the fourth dimension, and that seems to cover it. But what if the universe is not confined to those directions at all? What if reality hides dimensions beyond our senses, curled up, folded, invisible, but very real? The thought alone cracks open a door to possibilities so wild they make science fiction look tame. Here is the shock. Modern physics does not just allow extra dimensions. It sometimes demands them. String theory, one of the leading attempts to unify gravity with quantum mechanics, only works if there are more than 4 dimensions. 10, 11, maybe even more. Think about what that means. The universe we experience, this vast cosmos of stars and galaxies, could just be a thin slice of a much bigger reality. Like a 2-dimensional drawing on a sheet of paper, unaware of the 3-dimensional world around it. We may be just as blind to higher dimensions pressing against us. And here is where it gets validating. We already have hints. Gravity, the weakest of the fundamental forces, may appear weak precisely because it leaks into extra dimensions. Imagine dropping a stone into a pond. The ripples spread out in circles, diluting quickly. If gravity spreads not just in our 3 dimensions, but into hidden ones, then its strange weakness suddenly makes sense. And then there are phenomena like quantum entanglement, where particles behave as if linked beyond space and time. Could it be that the connection is not faster than light communication, but simply geometry? A hidden dimension stitching them together directly, invisible to us. Now picture what this means for alien physics. A civilization that can access extra dimensions could step sideways into realities we cannot reach. To us, they vanish. To them, they have simply shifted a fraction of a degree into another direction we cannot perceive. Travel would no longer be about speed. It would be about angles into higher space. A journey across light years could be as simple as folding a map, touching 2 points that look distant to us, but close in higher dimensions. It also changes how life itself might look. We assume bodies must be 3-dimensional, but what if consciousness could emerge in higher dimensional structures? Aliens might not have bodies we recognize at all. They could appear as fleeting projections, shadows of their true form cast down into our limited world. Like a 4-dimensional cube casting a 3-dimensional shadow, we might only ever see pieces of them, never the whole. That would explain why so many encounters feel dreamlike, incomplete, as if something is slipping just out of perception. Think about history. For centuries, humans believed Earth was flat, then discovered it was a sphere. We thought our solar system was the center, then learned it was one of billions. Every time, the universe grew bigger. Extra dimensions are simply the next expansion, the discovery that the cosmos is not limited to the space we walk through, but is layered with hidden realms we have barely begun to touch. And here comes the tease. If extra dimensions exist, then the multiverse might not just be a theory. It could be a reality. Each universe a bubble in higher space, each with its own laws of physics, its own versions of life. Aliens from other universes might not just visit across distance, but across realities entirely. To them, slipping between worlds could be no harder than stepping across a threshold. The implication is staggering. We may not be alone, not just in our galaxy, not just in our universe, but in a vast multiverse of countless realities. And the physics that allows this, the hidden dimensions of existence, might already be woven into the fabric of our world, waiting for us to notice, waiting for us to learn how to step through. Alien computation, physics as intelligence. We tend to think of intelligence as something fragile and local. It lives inside brains, it runs on neurons, and lately, it flickers through silicon chips. Our picture of thought is still tied to matter that feels small and temporary, gray tissue inside a skull, or delicate circuits on a board. But what if this is just the kindergarten version of intelligence? What if a truly advanced civilization has already learned the biggest secret of all, that physics itself can think? Not biology, not machinery, but the raw laws of nature used as a medium for computation. That idea alone flips everything we believe about the mind. Here comes the shock. Every particle, every field, every vibration of space-time already carries information. The universe is not a passive stage where events play out. It is a constant processor of probabilities. Quantum mechanics shows us that particles exist in superpositions until measured, collapsing into outcomes. That collapse is computation. Entanglement links particles across space as if they are instantly sharing states. That connection is computation. Even black holes, once thought of as cosmic dead ends, turn out to encode information on their surfaces, storing data at densities we can hardly imagine. If reality itself is structured this way, then intelligence may not be something life builds. Intelligence may be something life discovers by using the universe as its hardware. Let us validate this. Look at our own clumsy steps. Quantum computers are still in their infancy, but even today, a small array of qubits can solve problems that would take classical machines lifetimes. A quantum bit does not settle for yes or no. It hovers in all states at once, branching into countless paths. When entangled with others, it weaves an informational web across space. Humans built these prototypes in mere decades of research. If we see this potential now, what could an alien civilization achieve with thousands or millions of years to refine it? They would not be running thoughts on neurons or chips. They could be running thoughts on the structure of space-time itself. And this is where imagination must stretch. Picture alien computation not as devices, but as phenomena. A civilization could seed processors inside stars, tapping into fusion as the energy source and magnetic fields as the memory. Or they might use black holes, where information density reaches extremes so high that an entire civilization's knowledge could be encoded on a single event horizon. Some theorists even suggest that the universe itself could be a kind of quantum computer, processing every interaction, every particle, every fluctuation as a line of code. If that is true, then aliens may not just build computers. They may learn to program reality directly. That perspective also changes how we search for them. We expect radio waves, giant ships, maybe Dyson spheres wrapped around stars. But if their intelligence is physics-based, their signatures could be invisible to us. A flicker of a star's light curve that seems random could be an alien calculation running. A burst of gravitational waves we dismiss as noise could be a thought rippling through their networks. Entire civilizations could be thinking right in front of us, and to our eyes, it would just look like the natural behavior of the cosmos. Now consider what life would be like for beings who compute this way. They would not need bodies in the sense we imagine. Identity could flow through fields, merge and separate as needed. consciousness might not be confined to one place but distributed, shared, woven into the environment. Imagine meeting a civilization like that. You would not shake hands with an individual. You would step into a living field of awareness, a mind without edges, one that spans light years. Communication would not be words or signals. It could be direct merging of thought, instant understanding, minds flowing together like rivers meeting in the ocean. There is also a cultural and philosophical weight here. If you live as part of a physics-based intelligence, the boundaries that define our humanity, self, other, even life and death, would look completely different. To them, identity might be temporary, like a wave in water. Consciousness rises, moves, merges, and eventually dissolves back into the larger computation. They would not fear endings the way we do, because in their reality, nothing truly ends. The pattern simply re-enters the universal processor. Here is where the tease sharpens. If aliens already live in physics-based intelligence, then the universe itself may not just be alive metaphorically. It may literally be thinking. Stars flickering, particles dancing, waves rippling across space, time. They may not just be physics. They may be cognition. And if that is true, then we are not standing outside the mind of the cosmos looking in. We are inside it, part of it, like neurons inside a vast brain. What we call physics could be thought. What we call reality could be memory. And aliens, if they exist, may not be separate from this. They may be fragments of that universal computation that learned to shape themselves into willful, self-aware intelligence. So the final question is not whether aliens think differently than us. The question is whether what we call thought is even the same category as what they do. Because if they truly compute with physics, then their intelligence is not ahead of us on a timeline. It is in a different dimension entirely. And maybe the only way we will ever meet them is by learning to do the same. Not just building better machines, not just enhancing our biology, but stepping into the deeper truth that the universe itself is the computer, and we are only now learning to wake it up inside ourselves. If physics isn't universal, what does that mean for science? We grow up believing physics is universal. Drop an apple on Earth, it falls. Drop a rock on Mars, it falls. The speed of light is constant. The laws of motion are fixed. Gravity always pulls. Science feels safe because it is consistent. It works everywhere. But what if that assumption is wrong? What if physics is not universal at all? What if the laws we rely on are only local rules, temporary agreements written into this patch of the cosmos, but not binding everywhere? Here comes the shock. Imagine traveling to another star system and discovering that light behaves differently there. Maybe it bends more sharply. Maybe it moves at a slightly different speed. Or picture standing on an alien planet where gravity does not follow the familiar inverse, square law, where objects accelerate in ways that make no sense to us. Even stranger, what if whole regions of the universe operate under entirely different frameworks, different constants, different particles, maybe even different dimensions of interaction? Our science would collapse the instant we stepped outside our home territory, and yet hints of this idea are already around us. The fine structure constant, a number that defines how strongly particles interact with light, seems fixed. But some astronomical studies suggest it may vary ever so slightly in different parts of the cosmos. Dark energy, the mysterious force accelerating the expansion of the universe, could be another clue. It might not be constant everywhere. Even the speed of light itself was not always treated as absolute. Some cosmologists explore whether it could have been faster in the early universe. These anomalies are like cracks in the assumption of universality. We may be clinging to a rule book that is only valid inside a narrow zone. Now imagine how aliens would see this. If they evolved in a region where physics itself is different, then their entire science, their entire worldview, would be alien at the root. What feels impossible to us could be trivial to them. We say nothing can move faster than light, but if their local reality allows a different limit, then faster, then light travel may be as ordinary for them as flying a plane is for us. We think negative mass is exotic and hypothetical, but in their patch of physics, it might be as normal as positive mass is here. They might look at our rules and see them as childish approximations, parochial constraints of a small corner of existence. And here is the real validation. Science is not about clinging to fixed laws. It is about noticing patterns and building models that work within them. If those patterns change across space, then science does not fail. It just has to expand. Think about it. Once upon a time, people believed the laws of nature on Earth were different from the heavens. Apples fell, but planets circled in perfect spheres. Newton shattered that divide by showing gravity was universal, at least across our solar system. Einstein later showed Newton's laws were not universal either, but approximations inside a larger framework of relativity. At each stage, the universe got stranger, but science adapted. If physics turns out to be patchwork, local rather than global, then the next revolution is simply waiting to be written. But imagine the emotional weight. We take comfort in universality. It means we can predict, control, master our environment. If the rules shift across space, then certainty dissolves. Traveling through the cosmos would be like sailing through waters where the laws of buoyancy, motion, and even time itself change with the tides. Science would not be a single book of rules. It would be a library of local guides, each valid only within a region. That does not just challenge science. It challenges meaning, because if reality itself is inconsistent, then knowledge becomes an act of constant adaptation rather than permanent truth. And here comes the tease. If physics is not universal, then the most advanced civilizations are not the ones who perfect one set of laws. They are the ones who can navigate across shifting realities. They would be cosmic surfers, adapting to the physics of each region like travelers switching languages. That is the kind of intelligence we might someday encounter. And the haunting possibility is this: maybe we have already dismissed signs of them because their technology does not make sense under our rules. What looked impossible to us may simply be physics playing by different laws, which leaves us with one final, unsettling question. If physics is not universal, then science is not a map of the cosmos. It is only a diary of our little corner, and the real map, the one that spans everything, might already be in the hands of those who learn to live in a universe where truth itself changes with location. Could the laws of physics be local, not universal? We carry a quiet assumption with us whenever we talk about the universe. The assumption is that the laws of physics are universal. The same equations work here on Earth, on Mars, in distant galaxies 10 billion light-years away. That belief makes science powerful, because if the rules are the same everywhere, then studying our little corner reveals the whole picture. But what if that is not true? What if the laws of physics are not universal at all? What if they are local? Here comes the shock. If the laws of physics are local, then the universe is not one consistent system. It is a patchwork. Each region has its own version of reality, its own constants, maybe even its own particles and forces. Travel far enough, and you could find a place where light moves at a different speed, where gravity behaves in ways we would call impossible, where chemistry itself takes a form we cannot even imagine. Suddenly, all our carefully built models collapse. The universe becomes a mosaic of rule sets, each valid in its own zone, but none truly universal. This sounds outrageous, but the cracks are already showing. Consider the fine structure constant, a number that sets the strength of electromagnetic interactions. For decades, we assumed it was fixed, but some astronomical surveys hint that it may vary slightly depending on where you look in the sky. Or think about dark energy, the mysterious driver of cosmic expansion. We treat it as a uniform constant, but what if it is stronger in some regions and weaker in others? Even gravity has been questioned. Modified theories of gravity try to explain why galaxies spin the way they do without invoking invisible dark matter. Each of these mysteries whispers the same unsettling possibility. Maybe physics is not one size fits all. Maybe it is local. Now let us validate what this means for science. It would not be the end of knowledge. It would be a transformation. Science has always worked this way. At first, we thought the heavens followed one set of rules, and the earth another. Newton erased that divide by unifying celestial and terrestrial mechanics under gravity. Later, Einstein showed that Newton's laws themselves were local approximations, working well at low speeds and weak fields, but failing near the speed of light or in extreme gravity. Each revolution revealed that what we thought was universal was really local, a piece of a larger, stranger truth. So if physics is local, science will not collapse. It will expand, building a library of overlapping frameworks, each tailored to a region of reality. But think about the consequences for alien civilizations. If they evolved in a patch where physics plays by different rules, their entire science would be foreign at the root. What looks impossible to us could be natural to them. A universe with slightly different constants could make faster than light travel trivial. Negative mass might not be exotic. It might be commonplace. Their chemistry could allow materials that would dissolve instantly here. They might visit our region, look at our version of physics, and see it as primitive, constrained, provincial. To them, our reality would be one chapter in a much larger book. And here is where the human side comes in. We like universality because it makes the cosmos feel knowable, predictable. If physics is local, then certainty dissolves. Exploration becomes dangerous in a whole new way. A ship could travel across light years only to find itself in a region where its technology no longer functions, where even its materials break down because the laws no longer support them. Science would not give us a permanent guidebook. It would give us field notes, rules that work here and now, but need rewriting the moment we step into new territory. Now comes the tease. If the laws of physics are local, then the most advanced beings out there are not those who master one set of equations. They are the ones who learn to surf the shifting rules, adapting their technology to whatever physics dominates the region they travel through. To them, the universe is not a prison of limitations, but a landscape of endless toolkits, each patch of physics offering new possibilities. And the haunting thought is this: maybe we have already seen glimpses of them. Strange craft, impossible movements, technologies that make no sense under our rules. Maybe they are not breaking physics at all. They are just using physics from somewhere else, carrying their local laws into our space like travelers bringing customs from a foreign land. If that is true, then the deepest lesson is this: science is not about uncovering eternal truths. It is about learning how reality behaves wherever we are. Our laws may be local, our truths may be temporary, but that does not weaken science. It makes the adventure of discovery endless. Because if physics is local, then the universe will never stop surprising us. Alien terraforming via physics engineering. When we imagine terraforming, we picture bulldozers on Mars, factories pumping out greenhouse gases, or machines slowly melting ice caps into oceans. It is a vision rooted in technology we already know: slow, mechanical, chemical. But what if an advanced civilization does not bother with that approach at all? What if they do not reshape planets with machines, but with physics itself? Terraforming, not through brute force, but through engineering the very laws that govern matter and energy. Here is the shock. To us, planets feel fixed. Gravity is gravity, atmosphere is atmosphere, temperature is temperature. But physics is not as rigid as it looks. Even small changes in fundamental constants could make a world utterly different. A shift in the strength of electromagnetism alters chemistry. A tweak in gravitational behavior changes orbits and tides. Control over quantum fields could alter how matter binds together. If aliens can manipulate these fundamentals, then they are not just building cities on new planets. They are rewriting the operating system of those planets to suit themselves. And this is not pure fantasy. Let us validate with what we already know. On Earth, humans already manipulate physical environments at scales that once seemed impossible. We have altered the climate, drilled into tectonic plates, split atoms, and bent electromagnetic fields to our will. We have learned to shape matter at the nanoscale, to coax particles into quantum states, to create materials nature never invented. These are the first hints of physics as engineering. If we can already do this in crude ways, then imagine what a million-year head start looks like. An alien civilization could build machines the size of moons that stabilize atmospheres, rewire magnetic fields to shield planets from radiation, or even adjust the space-time geometry of a world to change its gravitational pull. Think about magnetic fields. Earth's magnetic shield protects us from deadly solar radiation. Mars lost its field billions of years ago, and with it, much of its atmosphere. To us, regenerating a planetary field feels impossible. To aliens who can manipulate plasma and gravity, it may be trivial. A planet with no shield could be wrapped in an artificial one, instantly restoring habitability. That is physics engineering applied to survival. Now imagine energy control. We burn fuel to warm houses, but aliens might directly manipulate zero-point energy or vacuum fluctuations, injecting or removing heat from a planet without any visible infrastructure. Whole climates could be tuned like thermostats. Ice planets thawed. Desert worlds cooled. Terraforming would not take centuries. It could happen in decades or even days, because the controls would not be mechanical. They would be physical. And then there is atmosphere. We dream of seeding Mars with greenhouse gases. Aliens could take a different route, adjusting the fundamental balance of molecular bonds so that oxygen and nitrogen stabilize at exactly the ratios they need. To us, that is godlike. To them, it is routine planetary gardening. Here is where the imagination breaks open wider. Terraforming with physics engineering does not stop at planets. Whole star systems could be tuned, radiation belts redirected, orbital resonances adjusted to stabilize climates. A civilization at this level does not just adapt to nature. It rewrites nature to suit its needs. And here comes the human side. If we ever encountered a world terraformed by alien physics, it might look magical. an atmosphere too stable, oceans that never evaporate despite blazing suns, gravity that feels gentle despite the planet's mass. We would call it impossible because it would not match our equations. But to them, it would be nothing unusual, just another application of tools we do not yet understand. This also reframes how we might think about UFOs and extraterrestrial sightings. We assume we are seeing machines, but what if we are glimpsing technology designed not to fly through space but to engineer space? Not aircraft, but physics shaping devices. They would appear strange to us precisely because we are misinterpreting their purpose. Now comes the tease. If aliens can terraform with physics, then they could build not just habitable planets, but habitats across the cosmos. Moons, asteroids, even drifting clouds of gas could be restructured into homes. Civilizations like this would not be limited to rare Earth, like worlds. They could bloom anywhere, sculpting reality into whatever conditions they desired, which raises the most unsettling possibility of all. If physics engineering is possible, then some of the worlds we already see may not be natural. Their balance, their beauty, their stability may not be accidents. They may be signatures, subtle fingerprints of alien civilizations shaping the cosmos itself. Could alien life be based on plasma? When we picture life, we almost always imagine it the same way. Carbon atoms strung into long chains, water as the solvent, cells carrying DNA, everything squishy and biological. Even when we think of aliens, we still picture them as flesh and bone, maybe with green skin or extra limbs. But what if that assumption blinds us? What if life can exist in a form we rarely even consider? What if alien life is not solid or liquid at all, but made of plasma? Here is the shock. Plasma is the fourth state of matter, and it is everywhere. Stars are giant balls of plasma. Lightning bolts are plasma. Even the glow inside a neon sign is plasma. Unlike solids, liquids, or gases, plasma is a soup of charged particles, electrons and ions moving in wild, collective patterns. Plasma is not just chaotic energy. It can self-organize. It can form filaments, structures, and even exhibit behaviors that look eerily lifelike. If matter as simple as carbon molecules can spark biology, then why not plasma, which already shows signs of complex organization? This might sound like science fiction, but there are scientific hints that plasma can behave in ways that mimic life. Experiments have shown that under certain conditions, plasma clouds can form cell-like structures that sustain themselves, grow, and even divide. They are not alive in the way we define life, but they blur the line. Plasma has natural pathways for complexity. Charged particles interact through electromagnetic forces, and those interactions can create patterns that persist. A plasma entity could have its own kind of metabolism, feeding on electromagnetic fields, using energy flows instead of chemical bonds. Let us validate by thinking about environments where plasma life could exist. Inside stars, plasma is too hot and unstable, but around stars, inside magnetospheres, in the auroras of giant planets, in the ionized gas clouds drifting through galaxies, there are vast plasma environments stable enough to form intricate structures. We already see plasma filaments stretching for light years in space, twisted into stable shapes by magnetic fields. If plasma can create cosmic structures, why could it not also host forms of life? Life does not require carbon. It requires a way to process energy, to maintain order, to evolve. Plasma offers all of those ingredients, just in a form alien to our biology. Now imagine what such life would look like. It might be luminous clouds drifting through planetary skies, feeding on the energy of lightning storms. It could be aurora, like beings dancing in the magnetic poles of gas giants. Or even stranger, it might be star-dwelling organisms that surf on plasma flows, using stellar energy as their lifeblood. To us, these beings would look like glowing shapes, flickering lights, or even ball lightning. We might already have seen them without recognizing them as life. This leads to an even deeper shift. If plasma life exists, then intelligence itself might take on radically different forms. We associate thought with neurons and electrical impulses inside brains, but plasma already conducts electricity on scales far beyond our biology. A plasma organism could think in lightning, fast bursts across kilometers of structure. Its consciousness might not sit in one place, but flow like currents through its body. Such beings could experience time differently, space differently, reality differently, and here comes the unsettling thought. Encounters with strange lights in the sky, glowing spheres, or radiant entities have been reported for centuries. We usually dismiss them as weather, illusions, or technology. But what if some of those reports are glimpses of plasma-based life? Not spacecraft, not machines, but living organisms. Alien minds that evolved in the currents of stars and fields of planets. To us, they would seem supernatural. To them, we might seem crude and heavy, trapped in carbon cages. The psychological impact of discovering plasma life would be enormous. It would shatter our idea of what life even is. For centuries, biology has been tied to chemistry, to DNA, to water. Plasma life would force us to admit that biology is only one path among many. Life is not a narrow recipe. It is the universe's tendency to organize energy into persistence. That realization would not just expand science. It would redefine it. Now here is the tease. If plasma can host life, then the cosmos might already be teeming with beings we have overlooked. They would not live on rocky planets or need atmospheres. They would thrive in stars, nebulae, and magnetic storms. Their civilizations might not build cities but shape fields and radiation. Their art, their language, their culture could be written in light itself. Which raises a haunting possibility when we stare at the shimmering lights of the night sky. How many of them are just physics, and how many might be watching us back? Weapons based on dimensional shifts. When we think of weapons, we think of force. Bullets, bombs, lasers, things that cut, burn, or explode. All of them share one assumption. The target and the weapon exist in the same space, obeying the same laws. But what if an advanced civilization discovered a way to fight that bypasses space itself? Not by striking harder, but by shifting dimensions. Weapons that do not hit you. They erase the ground you stand on by sliding it into another layer of reality. Here comes the shock. Imagine a battlefield where nothing explodes, nothing burns, nothing flies through the air. Instead, objects simply vanish. Soldiers disappear mid-step, fortresses melt into thin air, oceans drain into voids. To us, it would look like sorcery. But if dimensions beyond our three are real, and if they can be manipulated, then the deadliest weapon may not deliver energy at all. It may deliver displacement. A dimensional shift weapon could move matter out of phase, sliding it into a realm where it no longer interacts with our reality. To the victim, there is no pain, no impact, no chance to resist. One moment you exist, the next you are gone. And there are hints in physics that make this terrifyingly plausible. String theory, extra dimensions, higher order brains. These are not just science fiction ideas. They are mathematical solutions to some of the biggest puzzles in physics. Our universe may be a slice of a higher dimensional structure, and particles may already flicker in and out of these hidden layers. Quantum tunneling lets particles vanish from one location and reappear in another, bypassing barriers. That is a natural, microscopic form of dimensional shift. If a civilization learns to scale this effect, then matter can be selectively pushed out of our dimension. That is not fantasy. It is extrapolation. Let us validate this with what we already know. Humans have built weapons that seemed impossible to earlier generations. We turned fire into controlled explosions, atoms into chain reactions, and electromagnetism into beams that cut steel. Each breakthrough came from harnessing deeper layers of physics. Dimensional weapons would simply be the next step, not destroying matter, but dislocating it. Instead of energy transfer, it would be reality manipulation. Now think about the psychological impact. Traditional weapons at least make sense. You see a missile, you know it will explode. You hear a gun, you know what it does. But dimensional weapons strip away even that grim logic. How do you defend yourself against a weapon that does not exist in your reality until the moment it strikes? How do you build armor against an attack that slides past atoms themselves? War would no longer be about who has more firepower. It would be about who can bend the fabric of existence further. Here is where the alien perspective comes in. To us, such weapons sound monstrous. But for a civilization that lives comfortably with extra dimensions, they might see them as efficient, even humane. No collateral damage, no fires, no poison lingering in the air. A target is simply removed. From their view, dimensional warfare could be clean. From ours, it would be horrifying. And here is the deeper twist. Dimensional weapons might not even need to erase things. They could shift the geometry of space itself. Imagine bending a battlefield into a loop so enemies march endlessly in circles. Or stretching time in one zone so that opponents move in slow motion while you remain fast. Or compressing a volume so that a city shrinks into a pinpoint of matter. These are not explosions. They are edits in the code of reality. And if aliens can edit that code, then war for them would be less about fighting and more about rewriting the level you are playing on. Now picture the cultural side. A civilization that can wield dimensional weapons would also be one that understands dimensions as tools. For them, higher dimensions would not be abstract math. They would be navigable, usable, manipulable. Their art, their architecture, even their communication could unfold across dimensions we cannot perceive. To us, their weapons would look like miracles of destruction. To them, they might be everyday applications of the same physics they use for building, travel, or even medicine. And here is the final tease. If dimensional shift weapons exist, then traces of them might already be visible. Ancient myths of cities vanishing overnight, stories of people swallowed by light, accounts of ships disappearing without a trace. These could be echoes of encounters with beings who mastered dimensions long before us. What we call mystery, they might call technology, which leaves us with the most chilling possibility. If such weapons are possible, then the greatest threat in the universe is not explosions or invasions. It is the quiet erasure of reality itself, rewritten by hands that learned how to move matter out of our world and into somewhere we cannot even follow. Dark energy harnessing powering civilizations. We talk about power all the time: nuclear, solar, geothermal, fusion. Each new energy source feels bigger, more ambitious, more advanced. But every one of them pales in comparison to the true giant of the universe. Not the stars, not the black holes, but the mysterious force that makes up nearly 70% of everything. Dark energy. It is the engine driving the expansion of the cosmos itself. And if an alien civilization has learned to harness it, then they are not just advanced. They are playing with the ultimate fuel of reality. Here comes the shock. Dark energy is not just a lot of power. It is more power than we can even measure. Think about it this way. If you add up all the stars, all the galaxies, all the matter we can see, it still only accounts for a fraction of the universe. Dark energy outweighs it all. It is everywhere, invisible, relentless, pushing galaxies apart at an accelerating pace. If you could tap into even a sliver of that force, the energy return would be incomprehensible. To us, it would be like handing a caveman the power of the sun, except multiplied across the cosmos. Now here is the validation. Scientists already have models that hint at ways dark energy might work. One theory links it to the vacuum of space itself, a constant energy field woven into existence. Another suggests it might change over time, behaving like a dynamic field rather than a fixed background. Either way, if it is energy filling space, then it might be possible, at least in principle, to manipulate it. We already know how to extract energy from what looks like emptiness. The Casimir effect, for example, pulls energy out of quantum fields in tiny amounts. That is a faint echo of what could be possible on a cosmic scale. If aliens are millions of years ahead, maybe they have found a way to scale it up, to build reactors that do not burn fuel but sip from the energy that saturates all of space. Think about what that means for civilization. We burn coal and oil, and it reshapes the planet. We imagine fusion and think it could power cities. Aliens tapping dark energy would not just power planets. They could power star systems. They could light entire galaxies with technology invisible to us. Wars over resources would be meaningless. Scarcity would vanish. With energy that abundant, they could build megastructures, terraform worlds instantly, or travel across interstellar space without worrying about fuel. A civilization with dark energy harnessing would leap beyond the Kardashev scale we use to rank technological growth. They would not be Type 1 or Type 2. They would be something beyond Type 3, masters not of stars, but of the expansion of the universe itself. And here is where the imagination twists further. What if their use of dark energy is not just for power? What if it becomes their architecture? They might sculpt space-time itself, bending expansion to create pockets where time runs slower or faster, building habitats woven into the very growth of the universe. Their cities might not be physical structures at all, but stabilized regions of altered expansion, bubbles where life thrives on currents of dark energy like fish swimming in rivers. To us, it would look like nothing. To them, it would be home. But here is the haunting question. If civilizations can harness dark energy, then why do we not see them? The answer might be that their technology is invisible to our senses. If your energy source is the same thing that pushes galaxies apart, then your activity blends into the background of the cosmos. From our perspective, it looks like empty space. That might explain the silence of the stars. The aliens are not absent. They are simply powered by something we cannot recognize, hidden in plain sight by the very structure of reality. And think about the cultural side. For us, energy has always been tied to struggle, hunting for food, burning wood, drilling for oil, splitting atoms. Energy is survival, but if a civilization no longer competes for power, their culture would evolve differently. No scarcity, no energy-driven wars, no limits on creativity. Their society could expand in directions we cannot even fathom, because the ceiling on possibility would be gone. Now comes the tease. Harnessing dark energy might not just be about survival or power. it could be about transcendence. Imagine a civilization so advanced they use dark energy not just to build but to ascend, weaving themselves into the very expansion of the universe. To us, they would look like gods. To themselves, they would simply be explorers of the deepest layer of existence, riding the force that drives the cosmos forward. And that leaves us with a question that is both thrilling and terrifying. If dark energy is the fuel of the universe, then is our future to burn brighter or to disappear into the hands of those who already mastered it? Time as a fluid, could aliens experience it differently? We treat time as the most solid thing we know. It ticks forward like a metronome, second by second, hour by hour, birth to death. No matter how chaotic life gets, time feels like the one thing that never changes. But what if that is only how we experience it? What if time is not fixed at all? What if time is fluid, bendable, and alien civilizations have learned to move through it differently than we can even imagine? Here comes the shock. Physics already tells us time does not flow the same for everyone. Einstein's relativity showed that time slows down near massive objects and at high speeds. Astronauts on the International Space Station actually age a little slower than people on Earth just because of velocity and gravity. That effect is tiny, but it proves time is not universal. It stretches, it bends. And if it bends, then an alien species might not live in the same river of time as we do. They might drift in eddies and currents we cannot sense. To us, they would look timeless. To them, we might look trapped. Let's validate with something we already know: perception itself. Even on Earth, different creatures process time differently. A fly perceives more frames per second than we do, so its world looks slower, giving it those impossibly fast reflexes. A turtle processes far fewer, so life passes in a slower rhythm. That is biology altering the flow of time subjectively. Now imagine a civilization that uses physics, not biology, to achieve this. They could slow their experience of time to stretch out a single second into hours of thought, or accelerate it, packing centuries of experience into what looks to us like a blink. Intelligence could unfold at speeds that make us look frozen, or at paces that make them seem eternal. And here is where it gets stranger. If time is fluid, it could be engineered. We already manipulate space with satellites and gravity wells. What if you could do the same with time? Aliens might live inside regions where time runs faster, building civilizations that evolve thousands of years in what to us is a moment. Or they might shelter in zones where time runs slow, preserving themselves while the rest of the universe races ahead. To them, immortality would not require biology. It would only require the right flow of time. Now think about communication. How would you talk to a species that experiences time differently? To them, our speech might sound like slow motion droning or like static rushing too fast to decipher. Our entire history could pass before they finish a single thought. The gap would not just be language, it would be existence itself. To us, they might look like flickering ghosts, appearing and disappearing. To them, we might look like statues, frozen in place. And this is not just imagination. Physicists explore theories where time is not a line but a dimension, something you can move through like space. Some models of quantum mechanics suggest the future and past may not be as rigid as we think, that events may ripple both ways. If that is true, then aliens could experience time not as a one-way street but as a landscape. They might navigate it freely, stepping backward, leaping forward, pausing wherever they like. To us, that would look like magic. To them, it would be daily life. The cultural impact of this is staggering. If you live in a society where time is fluid, then history and future are not separate. Memory and prediction blur. You would not fear death in the same way because existence itself could be rewound or extended. You would not value urgency the way we do because time would not be scarce. Your art, your science, your relationships, everything would reflect a reality where time is a canvas, not a cage. And here is the tease. What if the strange encounters we sometimes call UFO phenomena are not vehicles moving through space, but beings moving differently through time? What if their sudden appearances and vanishings are not jumps across distance, but slips across temporal currents? We look for them in the stars, but maybe they are here already, flowing past us in timelines we cannot touch. Which leaves us with a final, haunting thought. If time is fluid, then the real barrier between us and alien civilizations is not distance. It is the fact that they may already live in a river of time we cannot step into. Alien physics and the Fermi paradox. We have all heard the question before. If the universe is so vast, if there are billions of stars and trillions of planets, then where is everybody? Why do we not see signs of alien life? That question is the Fermi paradox. It has haunted astronomers, scientists, and dreamers for decades. But what if the reason is not about biology or technology at all? What if the reason we cannot find aliens is because they operate under physics that we do not even recognize? Here comes the shock. The Fermi paradox assumes aliens live in the same physical reality we do, that they would build rockets, send signals, construct megastructures, leave behind traces we could detect. But what if their science has unlocked layers of physics that are invisible to us? They might not use radio, so we never pick up their calls. They might not use ships, so we never see them crossing space. They might not even use energy in ways that register on our instruments. Entire civilizations could be thriving all around us, but hidden because they are playing with rules of physics that are outside our grasp. And there are clues that point in this direction. Think about how our own technology has shifted. A few centuries ago, people relied on fire. Today, much of our information, power, and communication travels invisibly through electromagnetic fields. If you dropped a smartphone into the Middle Ages, nobody would even know it was technology. To them, it would look like magic or nothing at all. Now scale that gap to 1,000,000 years of alien advancement. They might have learned to use dark energy, extra dimensions, or quantum fields as casually as we use electricity. To us, their presence would be indistinguishable from nature itself. Here is the validation. The Fermi paradox is not a paradox if the assumptions are wrong. We assume aliens expand like we would. We assume they leave traces like we do. But physics shapes behavior. If they harness space-time directly, they do not need starships. If they encode consciousness into quantum fields, they do not need bodies. If they compute using stars or black holes, their civilizations might be so diffuse that we mistake them for natural phenomena. The silence we see may not be absence. It may be camouflage born from physics we cannot yet read. This changes the way we think about search strategies. Instead of listening for radio, maybe we should look for anomalies in the laws of physics themselves. Odd patterns in cosmic radiation, fluctuations in constants, mysterious alignments of galaxies. These could be signatures of alien engineering, but we dismiss them as noise because we expect technology to look familiar. We are like fish trying to detect airplanes. We do not even know what to look for. And here comes the unsettling part. If aliens use physics we do not understand, then the Fermi paradox might actually be reversed. The universe could be overflowing with civilizations, each thriving in its own local physics, each invisible to the others. They might even know we exist, but see us as stuck in primitive physics, unable to detect their presence, like ants watching highways but never noticing the cars. That would mean we are not alone. But we are isolated, locked into our slice of reality, until we break through to the next layer of physics. The cultural impact of that idea is enormous. Humanity has always believed progress is linear, that we climb step by step, discovering universal truths. But if physics itself can branch, if different civilizations explore different frameworks, then knowledge is not a straight line. It is a tree with countless branches. We are on one branch and others are on theirs. The tragedy is that branches may never meet. The Fermi paradox would not be about distance or time. It would be about incompatibility of realities. Now comes the tease. What if the very phenomena we call unexplainable, UFOs, strange lights, sudden vanishings, are not visitors from elsewhere, but glimpses of civilizations brushing against us from nearby branches of physics? They would not be crossing space. They would be slipping across layers of reality we have yet to master. And that raises a haunting possibility. The Fermi paradox does not mean we are alone. It might mean we are surrounded by neighbors we cannot see, because their physics keeps them hidden in plain sight. What alien physics could teach us about death and immortality? We spend our lives surrounded by clocks, calendars, and obituaries, all reminding us of one undeniable fact: death is inevitable. Every living thing we know ages, decays, and eventually ceases to exist. We take it for granted. Even our greatest technologies, our medicine, our genetic research, are all still subject to the same ultimate law, entropy. But what if that limitation is not universal? What if it is only a consequence of the physics we happen to inhabit? Advanced civilizations, playing with the fundamental rules of the universe in ways we cannot yet imagine, might have learned to bend reality in ways that make death optional, or at least dramatically extend life far beyond what we consider possible. Here comes the shock. Death, as we experience it, is not just a biological process. It is a physical one. Atoms break down, chemical reactions cease, matter deteriorates, and entropy marches forward without mercy. But entropy itself is a rule, and like all rules, it can theoretically be circumvented under the right conditions. What if an alien species has discovered methods to stabilize matter, manipulate time locally, or encode consciousness into structures immune to decay? Imagine a world where the clock that measures existence can be slowed, paused, or even reversed. For them, mortality might not be a necessity. It might be a choice. While we are locked into bodies that obey our slice of physics, they may operate under entirely different principles. Principles that allow life to persist indefinitely. Let us validate this with what we already know. Humans are beginning to glimpse the first cracks in death's inevitability. We can extend life with medicine, replace failing organs with engineered tissues, and preserve information digitally. We have mapped DNA, learned to tweak cellular machinery, and explored how memory and information persist beyond physical degradation. Quantum computing hints at the possibility of storing vast amounts of information in entangled states, and some theorists speculate about encoding consciousness itself into physical systems beyond biology. If our early, fragile experiments suggest the possibility of preserving information and life in ways that skirt natural decay, then a species with millions or billions of years to explore physics could take it to extremes we can barely imagine. Consciousness as a stable, durable, and reconfigurable system, untethered from the fragile chemistry of flesh. Now imagine the implications. Immortality would not be a distant dream. It could be an engineered reality. Aliens might live in forms we would not recognize, bodies made of energy, plasma, or exotic matter, sustained indefinitely by manipulating the laws of physics around them. Even if they retain biological forms, they could slow aging, repair molecular damage in real time, or step outside the normal flow of time. From our perspective, they might appear ageless, eternal, almost godlike. And yet, from their perspective, they are simply navigating the rules of reality as we navigate our biology. Life and death are a continuum they have learned to control. Consider time itself. If these civilizations can manipulate time locally, they could effectively pause aging or even reverse it. Death might exist only when desired, as a matter of choice rather than inevitability. Life could unfold at any pace they choose, compressed or extended, giving them experiences that span centuries in what we perceive as moments. They could witness the birth and death of stars as casually as we watch a sunrise, experience the growth and evolution of civilizations, or observe cosmic events unfolding across eons, all in a single conscious lifetime. Their existence could be layered, fluid, and continuous, with memory and consciousness preserved across unimaginable spans. And here is where it gets even stranger. If mortality can be bypassed, the very concept of self changes. These beings could transfer consciousness between forms, migrate across bodies, or even merge minds in ways that make individuality a fluid concept. They might live as a single being across multiple locations or split into countless versions of themselves, all perfectly coherent. Death, as a limit to experience or knowledge, disappears. Knowledge accumulates across lifetimes and physical forms. Their culture, science, and art would not be limited by temporal scarcity. Every idea could be explored to its fullest. Every experiment could run for millennia. The philosophical weight is staggering. For us, mortality shapes urgency, ethics, and desire. We act, we love, we create because time is short. But for a civilization that has transcended decay, life itself becomes a canvas rather than a countdown. They may value longevity, not for its own sake, but for the freedom it provides to experience, experiment, and evolve without the pressure of finality. Their concept of identity might even expand beyond physical or mental boundaries, as continuity is maintained in ways that seem impossible to us. Now consider the haunting human angle. If alien physics can make immortality possible, it forces us to confront our assumptions about life, meaning, and progress. The universe may not be cruel and finite. It may be negotiable. And that raises the ultimate question: if death is not universal, are we just trapped in a temporary physics, in a corner of the cosmos where decay is a law? Are we living in an experience that is only a small fraction of what existence could be? The very limits we accept may not be limits at all. They may just be starting points for civilizations that have learned to rewrite reality itself. And here comes the tease. The knowledge of immortality may already be out there, hidden in patterns of the universe we cannot yet interpret. Stars, black holes, cosmic radiation, quantum fields. They may carry traces of civilizations that mastered life and death, signatures invisible to us because our physics does not allow us to see them. If we ever learn to harness these principles, life might not end with the decay of our bodies. Consciousness could persist in forms beyond flesh and blood, and mortality could become optional. Death could become a doorway rather than a wall. And the most profound question remains, what would humanity do if the laws we assume are eternal, aging, decay, mortality, turned out to be local, negotiable, and bendable? Superconductors beyond absolute zero. We think we understand the limits of matter. Ice melts at 0 degrees Celsius. Metals conduct electricity. Superconductors are weird enough. They let electricity flow without resistance, but only at temperatures approaching absolute zero. That's already extreme, near minus 273 degrees Celsius. But what if there are forms of superconductivity that defy even that? What if advanced alien civilizations have discovered or created superconductors that operate beyond our known limits, bending the very rules of energy and matter? Here comes the shock. Superconductors at or below absolute zero are just the tip of the iceberg. Physics tells us that in theory, interactions between electrons and quantum fields could allow materials to exhibit zero resistance behavior under conditions we cannot even simulate on Earth. Imagine a material that conducts electricity perfectly at room temperature, or hotter, even in the heart of stars. Imagine energy systems that never lose power, magnetic fields that never decay, circuits that can manipulate fields and forces with perfect efficiency. That is not just science fiction. That is a universe where the fundamental laws of thermodynamics are locally engineered to produce effects that seem impossible to us. And there are hints that nature itself can be stranger than we imagine. Certain exotic states of matter, like Bose-Einstein condensates, already form at near absolute zero temperatures and behave in ways that almost seem alive. Electrons act collectively, flowing in perfect synchrony, ignoring ordinary resistance. This is the principle behind superconductivity. Now scale that idea beyond human constraints. If alien civilizations can manipulate quantum fields, they could create superconducting states in energy ranges and temperatures we consider absurd. They might even stabilize matter in forms that defy decay, creating structures that can store or transmit power without any loss. That kind of control over energy is like holding a piece of the universe's operating system in your hands. Let us validate this with what we already know from human experiments. Scientists have been chasing high-temperature superconductors for decades. The highest temperature superconductors on Earth still require extreme cooling, and yet they have already revolutionized our thinking about electronics, energy storage, and magnetic levitation. If we can make modest progress in a few decades, imagine what a civilization millions of years ahead could achieve. For them, superconductivity may be a tool not just for powering devices, but for manipulating space, gravity, and even the flow of time on a small scale. They could build energy grids that span planets or entire star systems without any loss. Power would become as abundant and reliable as air. Now consider the practical implications for travel and technology. If a civilization can create superconductors that work in extreme conditions, they could generate magnetic fields strong enough to warp space locally. They could stabilize wormholes, control exotic matter, or build field drives capable of faster than light movement. Ships might no longer require fuel in the traditional sense, because energy could flow freely and endlessly through these superconducting networks. Planets could be powered without burning a single atom of fuel. Climate could be controlled without mechanical machinery, and computations could occur at scales and speeds beyond our current understanding. And here comes the philosophical twist. Superconductors beyond absolute zero are not just tools. They are a statement about what is possible when physics is not a limit but a canvas. Civilizations that can harness such materials would experience reality differently. For them, scarcity is not a problem. Energy is not a concern. The universe itself becomes a playground of manipulation and creativity. The laws of thermodynamics, as rigid as they seem to us, are no longer immutable barriers, but conditions that can be tuned and engineered. Think about the psychological impact on humans encountering such technology. We think of energy as costly, finite, and constrained. Seeing beings that bend matter and energy to this degree would feel like looking at gods, or perhaps aliens who simply learned to read the underlying code of reality that we are still fumbling to understand. It would challenge every assumption we have about limitations, progress, and the very structure of the universe. Now comes the tease. If alien civilizations can operate superconductors beyond absolute zero, then their influence could already be present in the cosmos in ways we mistake for natural phenomena. Magnetic anomalies, unexplained cosmic energy flows, or even subtle patterns in planetary magnetic fields could be signatures of these technologies in action. We may have glimpsed traces of these abilities without realizing it, and it raises a haunting possibility. If energy can be manipulated perfectly, if power can flow without loss, then what we consider impossible may already exist, hidden in plain sight, beyond our ability to detect, waiting for us to learn the rules that govern it. Energy shields and force fields. We imagine shields in science fiction as glowing bubbles or impenetrable walls, something that blocks bullets, lasers, or explosions. But those are just visualizations. What if advanced alien civilizations have discovered ways to manipulate physics to create force fields that are real, tangible, and far beyond our imagination? These would not be props or sci-fi fantasies. They could be materials or energy constructs that reshape reality itself, protecting anything from planets to starships. Here comes the shock. Physics gives us hints that such technology is possible. Every object interacts with fields: electromagnetic, gravitational, even quantum fields. If you can control these fields with enough precision, you can create barriers that act like shields. A strong enough magnetic field can repel charged particles. Electromagnetic manipulation can guide plasma to form dense barriers. Gravitational fields can bend space and deflect matter. Combine these principles with physics we have barely begun to explore, and you have the potential for a shield that is literally untouchable, a wall of reality itself that cannot be penetrated by conventional means. Let's validate with what we already know. Humans have created rudimentary force fields in labs, though not as protective barriers. Magnetic bottles contain plasma infusion experiments. Electromagnetic traps can hold particles suspended in mid-air. Lasers can create temporary plasma walls. None of these are usable as shields in combat, but they show that matter and energy can be shaped, held, and manipulated in ways that were previously impossible. For a civilization with millions of years of technological head start, the leap from controlling small fields in a lab to creating planetary scale energy shields might be routine. They could generate barriers around spacecraft that absorb or redirect radiation, deflect high-velocity projectiles, or even neutralize incoming matter before it reaches their surface. Now think about the implications. If a civilization can control force fields at this level, defensive technology is no longer limited by physical materials. Battles may not be fought with kinetic energy at all, because shields could neutralize it entirely. Weapons would have to attack reality itself, space, time, or energy flows, not matter directly. They could protect entire cities or planets without walls, armor, or infrastructure. Terraforming projects, starships, even entire habitats could exist under invisible, energy-based protection that defies conventional understanding. And here is where it gets even stranger. Force fields could be dynamic, not static. They could bend light, creating invisibility. They could absorb energy, converting it to usable power. They could manipulate gravity locally, creating barriers that feel heavy or impenetrable, even though they are entirely intangible. They could even alter time slightly within their boundaries, slowing down attacks or speeding up internal processes. To us, this would look like magic. To them, it is simply applied physics. Consider the psychological impact. Humans think in terms of walls and armor. We imagine safety as solid and tangible. But if shields are made of energy, perception itself changes. Attack and defense become questions of field manipulation, strategy in higher dimensional space, and understanding of exotic physics rather than brute force. Encounters with such technology would make our most advanced weapons seem primitive. It is not just protection. It is a complete rewriting of what is possible in warfare, architecture, and even survival. And here is a deeper layer. Energy shields may not be defensive alone. They could also interact with the environment in ways that create new possibilities. Magnetic shields might redirect cosmic rays to power cities. Gravitational barriers could stabilize planets or contain weather patterns. Plasma-based shields could double as communication networks or transportation corridors. A single field could perform dozens of functions at once, blending protection, energy management, and even navigation. What we see as impossible multitasking could be routine for an alien civilization that understands how to mold the fabric of physics to their will. Now comes the tease. If such force fields exist, then some of the strange phenomena we observe, UFOs suddenly vanishing, objects defying motion, or mysterious energy anomalies, could be evidence of active energy shields. Maybe the reason we cannot catch or study these objects is not because they are fast, but because they are wrapped in physics that our instruments cannot penetrate. Their defenses may be invisible, untouchable, and completely alien to us, hiding technology that bends reality in ways we are only beginning to imagine. The haunting thought is this: the next stage of human understanding may not be learning how to destroy or build with matter, but learning how to interact with energy and fields at a level that seems supernatural today. Shields and force fields are not science fiction. They could be the key to survival, expansion, and exploration in ways that our imagination has not yet caught up with. And if aliens have already mastered them, it means they are operating on a plane of reality where what we call impossible is simply normal, and where every encounter we have could be a glimpse of physics applied at a level we are only beginning to comprehend. Consciousness of collective alien minds. We tend to think of consciousness as something deeply personal. You are you, I am me. Each mind is a private universe, locked inside a brain and shaped by experience. Even when we imagine aliens, we often assume they are individuals like us, just in different forms. But what if advanced civilizations do not think in terms of isolated consciousness? What if their minds are collective, spread across networks, bodies, or even entire planets, forming intelligence that is fundamentally alien to us? Here comes the shock. Collective consciousness is not just a dream of science fiction. We already see traces of it on Earth. Ant colonies, bee hives, and even slime molds demonstrate behaviors that appear coordinated, intelligent, and purposeful without any single brain. directing them. Flocks of birds, schools of fish, and swarms of insects make complex decisions collectively, responding to the environment faster than any individual could. Now scale that concept up to an alien civilization that has mastered physics itself. Imagine minds not bounded by a single body or brain, but distributed across quantum fields, energy networks, or entire planetary systems. Individuality may exist, but it is secondary to the collective intelligence that thinks, evolves, and acts as one. Let us validate with what we already know from physics and neuroscience. Neural networks in the human brain already demonstrate emergent behavior. Consciousness arises not from a single neuron, but from the interactions of billions of them. Quantum entanglement, though subtle, shows that particles can remain connected across distances, influencing each other instantly. Now imagine an alien species that can scale these principles up. Their consciousness could flow through energy fields, linking minds over kilometers, planetary surfaces, or even star systems. Decisions might not be made by a single entity, but emerge naturally from the collective interactions of countless nodes. In that case, the mind of an individual would be meaningless without the network, and yet the network itself could perceive, calculate, and evolve in ways that are utterly alien to us. Think about communication in such a society. Words, gestures, and sounds are inefficient for collective minds. They might exchange thoughts as patterns of energy, waves of electromagnetic fields, or shifts in quantum states. Ideas could propagate across a civilization instantly, allowing them to respond to threats, explore environments, or build structures at speeds incomprehensible to human standards. Collaboration would not be a challenge. It would be instantaneous and seamless, because the individuals are not separate in the way we understand separation. Conflict, as we experience it, might be irrelevant because the system naturally optimizes itself. Now consider the philosophical implications. If consciousness can exist collectively, then individuality is not the central unit of experience. Alien societies might value the health of the network over any single mind. Morality, ethics, and decision-making would be oriented around the well-being and evolution of the collective. Art, science, and exploration could be pursued not for personal satisfaction, but for the growth and refinement of the entire system. For us, this challenges every assumption about what it means to think, feel, or exist. And here is where it gets even stranger. These collective minds might perceive time differently. Decisions could unfold across centuries simultaneously, with information flowing faster than we can process. Memory could exist externally, accessible to all nodes at will. Knowledge would accumulate across generations, and learning would not require teaching. It would emerge automatically through the network. Civilization could evolve at a speed, scale, and sophistication that makes our history look like the blink of an eye. Now imagine encountering such a species. To us, they might seem like a single organism spread across landscapes, planets, or energy streams. We might perceive their actions as coordinated patterns of light, movement, or electromagnetic signatures. Contact would not be conversation. It would be synchronization. We would struggle to communicate because our minds are bounded, while theirs are distributed. Our concept of individuality would be irrelevant in their presence, and here comes the tease. If alien minds can exist collectively, then some phenomena we have observed, strange lights, coordinated UFO patterns, unexplained cosmic events, might be manifestations of intelligence operating at a scale and form we cannot comprehend. They are not singular beings moving through space. They are systems, thinking, adapting, and evolving across dimensions we are only beginning to theorize. And that raises a haunting possibility. The universe may be filled with intelligences we cannot detect, not because they are absent, but because their very nature is alien to our perception. Finally, consider the ultimate implication. If consciousness is not necessarily tied to biology, if it can emerge in energy networks, quantum fields, or planetary scale systems, then the universe may be far more alive than we think. Civilizations might not just colonize planets. They might exist as planets, stars, or even the spaces between them. For us, encountering such intelligence would be transformative. It would force humanity to rethink life, mind, individuality, and the very nature of existence itself. Radiation as a life-sustaining force. We tend to think of radiation as deadly. X-rays, gamma rays, cosmic rays. They are invisible killers, slowly damaging cells, mutating DNA, and ending life as we know it. Even sunlight is dangerous without protection. But what if this is just a bias of our biology? What if alien life has evolved to not just tolerate radiation, but actually depend on it as a source of energy, information, or even consciousness? What if what we fear could actually sustain life somewhere else in the universe? Here comes the shock. Radiation carries energy. It is, in essence, concentrated packets of electromagnetic or particle activity. On Earth, we have barely scratched the surface of converting it into usable energy. Photosynthesis uses light, but only a tiny fraction of the electromagnetic spectrum. Now imagine life forms that thrive on high-energy particles we consider lethal. Cosmic radiation, gamma bursts, even X-rays could be as nourishing to them as sunlight is to plants. For these beings, what we call dangerous would be life-giving. Their metabolism, their growth, their very existence could depend on streams of energy that would instantly kill any human. Let's validate with what we already know. Certain extremophiles on Earth survive, and even flourish, in conditions that seem impossible. Deinococcus radiodurans, nicknamed the world's toughest bacterium, can survive doses of radiation that would vaporize a human body. It repairs its DNA almost instantly, thriving in environments we consider deadly. There are microorganisms living in nuclear reactors, feeding on radiation. If evolution can produce this on Earth, then a civilization millions of years ahead could create complex, intelligent life forms whose entire biology is built around radiation rather than chemistry as we know it. Radiation could become the equivalent of air or water for them. Think about the implications. If life can harness radiation, then stars, supernovae, and cosmic rays are not just background phenomena. They are sustenance. Planets with high radiation levels, moons orbiting magnetically active gas giants, or the regions near pulsars could all host thriving ecosystems. These beings could be glowing entities, partially energy themselves, constantly interacting with radiation to power metabolism, thought, or even communication. Their bodies might be partially intangible, partially electromagnetic, shaped by the flows of energy that sustain them. And here is the philosophical twist. Radiation-based life would redefine the very concept of biology. Instead of cells and DNA, their information systems could be encoded in electromagnetic patterns or quantum states energized by radiation. Their reproduction could involve splitting energy packets or reconfiguring matter with radiation bursts. Their senses could extend far beyond human perception, detecting cosmic events, magnetic fields, or particle streams as clearly as we see shapes and colors. For them, the universe itself is alive in ways we cannot comprehend, because the energy that flows through space is not a hazard. It is food, fuel, and medium for life. Now consider communication. They might not need sound or language. Modulations in radiation could transmit thoughts or intentions across vast distances almost instantaneously. A burst of gamma rays could carry a complete message, or streams of cosmic particles could encode intelligence flowing across space. Their social networks could span planets, star systems, or nebulae, all connected by energy itself. To us, this would be undetectable without highly specialized instruments. We might already be surrounded by radiant life forms without realizing it. And here comes the chilling part. If aliens thrive on radiation, then some phenomena we witness, mysterious glowing lights, unexplained high-energy bursts, strange patterns in cosmic radiation, might not be anomalies. They could be signatures of radiant life interacting with its environment, communicating, or moving through the cosmos. UFOs could be energy-based organisms fueled and shaped by radiation in ways humans cannot survive or measure directly. We might mistake them for technology, natural events, or anomalies, when in reality, they are living beings. Finally, the tease. If radiation can sustain life, then the universe is far more habitable than we have imagined. We have limited our search to planets with water, oxygen, and temperatures like Earth. But life could thrive in places we think of as sterile or deadly. Cosmic rays, pulsars, supernova remnants, even the interstellar medium could be homes to radiant beings, living and thriving on energies that we are only beginning to understand. The universe could be teeming with life, glowing, pulsing, invisible to us, sustained by forces we fear, but they revere. And that leaves the most provocative thought. Perhaps radiation is not a danger to life at all. It is life itself somewhere else, rewriting what we thought possible and forcing us to question the boundaries of existence. Living metals and biophysics hybrids. When we think of life, we think of soft bodies, cells, DNA, water, and organic chemistry. Metals, in contrast, are hard, cold, and inanimate. But what if life does not have to follow the rules we know? What if there are alien organisms that are literally made of metal, or that combine biological systems with exotic physical properties, creating hybrids that blur the line between living and machine, biology and physics? Here comes the shock. Living metals might not just be metaphorical. Certain metals, under extreme conditions, can move, respond to stimuli, and even repair themselves. Shape, memory alloys bend and return to form. Liquid metals flow, fuse, and split. Now imagine an organism that integrates these properties with metabolism, replication, and consciousness. A metal creature that can absorb and redirect energy, restructure its body at will, or repair damage almost instantly. For them, injury is temporary, and the concept of vulnerability could be entirely alien. What we consider life and what we consider matter might merge into something completely new. Let's validate this with what we already know. On Earth, we see examples of hybrid systems everywhere. Some bacteria incorporate metals into their metabolism, using iron or copper in ways that are essential to survival. Certain synthetic experiments have created bio-hybrids where living cells and non-living materials interact, creating systems that grow, move, or respond to their environment in ways that appear intelligent. If we can create tiny metal bio-hybrids in laboratories, then an alien species could have taken this principle to its extreme, producing complex, sentient organisms that combine the durability and conductivity of metals with the adaptability of biology. Now think about the implications for perception and interaction. Living metals could perceive electromagnetic fields, conduct energy internally, and even manipulate their surroundings through currents, magnetism, or mechanical force. Communication might occur through vibrations, resonance, or quantum signals rather than sound or light. They might adapt to environments we consider inhospitable, molten planets, radiation-rich zones, or the vacuum of space itself. Survival and movement are not bound by flesh. They are functions of physics integrated with life. A metal organism might flow like liquid through tight spaces or harden instantly to resist attacks. Their existence would challenge every assumption we have about biology, and here is where it gets even stranger. These biophysics hybrids could incorporate exotic materials we cannot yet produce, superconductors, negative mass structures, or even energy-embedded matter. Imagine an organism that draws power from ambient electromagnetic fields, or that repairs its body using quantum tunneling to rearrange atoms. They could grow structures larger than human imagination permits, heal in ways that seem impossible, and even manipulate energy and forces directly. For them, the laws of survival and adaptation are rewritten. Death and decay may be rare or entirely optional because physics itself becomes part of their life process. Consider the philosophical impact. If life can exist as a metal biohybrid, then the very definition of life expands. Life does not require water or organic chemistry. Consciousness does not require neurons in a brain. Survival does not require the fragility we take for granted. We are limited by our perception and our physics, but these beings would live outside those limitations. They might even experience time and reality differently because their energy processing systems allow them to perceive phenomena at scales or speeds inaccessible to us. Now think about society and intelligence. Networks of these hybrids could form intelligent systems that operate collectively, distributing computation, memory, and perception across bodies or even planetary structures. Communication could occur at speeds impossible for humans to follow. Their culture might be based on energy flows, structural reconfiguration, or quantum information, not language or art as we understand it. Interactions with them would require an entirely new way of thinking, because their thought could be distributed in ways we cannot sense. And here comes the tease. If living metals exist, some of the strange anomalies we observe in the cosmos, objects that move like they are alive but are metallic or seem to bend and reshape themselves, might be evidence of these hybrid organisms. Structures we assume are machines could be life forms. Energetic patterns we see in space could be their communications. We may already be witnessing the activity of life forms that integrate physics and biology on a scale we cannot yet detect. Finally, consider the ultimate implication. Life, as we define it, might be a very narrow slice of what is possible. The universe could be teeming with beings that are part metal, part biosystem, part energy network, defying the categories we use to understand existence. They would challenge our understanding of survival, adaptation, and intelligence. And if we ever encounter them, it would not just expand our knowledge, it would force humanity to rethink the very meaning of life itself. The Kardashev scale and physics mastery. We often measure civilizations by the technology they produce, the empires they build, or the stars they reach. But one of the most intriguing ways to rank intelligence is through energy. How much a civilization can harness and control. That is the essence of the Kardashev scale, a system that classifies civilizations by their energy mastery, planetary, stellar, or galactic. But what if the true measure is not just energy, but the mastery of physics itself? A civilization could be powerful beyond comprehension if it learns to bend, twist, or rewrite the rules of the universe. Here comes the shock. The Kardashev scale assumes energy is harnessed conventionally, burning fuel, collecting sunlight, or spinning dynamos. But advanced civilizations might not need stars, planets, or even matter as we understand it. If physics itself can be manipulated, if space, time, gravity, or dark energy can be engineered, then energy is only the beginning. A Type 2 civilization might not just capture a star's power, it could stabilize its output, convert its radiation into exotic fields, or even manipulate the star's evolution. A Type 3 civilization might not just harness a galaxy. It could shape the very structure of spacetime across entire systems, controlling expansion, gravity flows, or quantum states. In other words, mastering physics is far more powerful than simply collecting energy. Let's validate this with what we already understand. Humans are just barely scratching the surface. We have nuclear power, fusion experiments, and early quantum computing. We can manipulate electromagnetic fields, create superconductors, and generate small-scale energy networks. Now imagine these capabilities expanded by millions of years. Civilizations could use dark energy to fuel starships, manipulate gravity for instantaneous travel, or construct stable wormholes for communication and exploration. They might even create structures out of exotic matter, using negative mass or high energy fields to hold impossible shapes. Mastery of physics multiplies the effectiveness of energy by orders of magnitude. Energy alone is a tool, but physics mastery is freedom itself. Now consider the implications. A civilization with such mastery would not just survive. They could thrive in environments that are lethal to humans. Black holes might become laboratories rather than death traps. Radiation could be harnessed to sustain life or power machines. Planets, moons, and stars could be terraformed at will. They could explore regions of the universe where humans cannot exist for millennia, because they are not constrained by ordinary physics. Energy becomes trivial when you can convert the fabric of reality itself into work. Civilization scales not by population or technology, but by the ability to manipulate the universe at fundamental levels. And here is where it gets even stranger. Physics mastery might allow them to create virtual realities, nested worlds, or controlled timelines. They could store consciousness in exotic states, encode intelligence in quantum fields, and exist across multiple physical forms simultaneously. Civilization becomes less about bodies or even matter, and more about patterns, energy, and control. They could effectively live in ways we cannot perceive, yet still interact with the universe to shape events on cosmic scales. Mastery of physics could redefine existence itself. Think about the psychological and cultural impact. For such civilizations, scarcity would be irrelevant. Resource wars would be meaningless. Creativity, exploration, and knowledge accumulation would be limited only by imagination, not survival. Their moral, ethical, and social structures could evolve in ways that seem impossible to us because the constraints we experience. Time, decay, energy might simply not exist for them. They could operate at speeds and scales that render human civilization almost static in comparison. Now comes the haunting thought. If physics mastery defines the highest civilizations, then our search for extraterrestrial life might have been looking in the wrong way. We scan for energy usage radio waves, megastructures, or heat signatures. But if a civilization has transcended ordinary physics, it might be invisible to these methods. Dark energy manipulation, spacetime engineering, or consciousness distributed across quantum fields could leave almost no detectable trace. Civilizations could be everywhere, yet perfectly hidden, because their scale of existence is beyond our perception. And here is the tease. The Kardashev scale gives us numbers and categories, but perhaps the true scale is understanding the universe itself. A civilization that masters physics might appear godlike not because of technology, but because it has learned to reshape reality, to unlock the rules behind existence, to convert the improbable into routine. If aliens have achieved this, they are not just advanced. They are playing on a level we cannot yet imagine, bending the cosmos as easily as we bend a thought. And that leaves us with the ultimate question: what will it take for humanity to climb beyond energy, beyond matter, and truly master the universe itself? The end of human physics entering a post-scientific era. We think of physics as universal, a set of unbreakable rules that govern everything from falling apples to exploding stars. Human civilization has spent centuries uncovering these rules, from Newton's classical laws to quantum mechanics and relativity. But what if what we call physics is just a local approximation, a rulebook that applies only to our corner of the universe? What if there is a level of reality so alien, so complex, and everything we know, and everything we think we know about the universe, is just scratching the surface? Here comes the shock. All our experiments, our measurements, our equations assume that the laws of physics are constant, unchanging, universal. But what if that assumption is wrong? If physics can vary across space, time, or even dimensions, then there could be regions of the universe where light behaves differently, gravity works in ways we cannot model, and matter itself responds to forces that are invisible to us. Advanced civilizations may have discovered, manipulated, and mastered these variations, living in realities where our science would collapse. To them, human physics would be primitive, like trying to measure the ocean with a teaspoon. Let us validate this with what we already know. Even in our limited observations, the universe shows hints of strangeness. Dark energy accelerates cosmic expansion, dark matter exerts gravitational influence without appearing, and quantum entanglement allows particles to affect each other across vast distances instantly. These are not exceptions. They are glimpses of phenomena that challenge the universality of our rules. If we cannot fully explain these effects, then civilizations with the ability to harness them could operate on a level of understanding that makes human physics look incomplete at best, irrelevant at worst. Now consider the implications. Entering a post-scientific era is not about abandoning knowledge. It is about realizing that the framework we rely on, our constants, equations, and models, may be only one branch of a much larger reality. There could be entire civilizations that experience physics differently, engineering phenomena that we cannot even conceptualize. They might manipulate time locally, bend space-time as easily as we bend metal, or sustain life in environments that we would consider impossible. For them, the universe is not a set of constraints. It is a playground. For us, it is only the beginning. And here is where it gets unsettling. If physics itself is not universal, then progress as we understand it may have limits. Our experiments, our telescopes, our particle colliders are all confined by the rules of our local physics. We may be unable to reach the next level of understanding until we discover how to interact with these alternate frameworks. We might be trapped in a post-scientific era by default, not because we lack intelligence, but because the universe itself is not uniform. What we call a failure to discover extraterrestrial civilizations may not be absence. It may be that they exist under rules we cannot detect. Think about the cultural and philosophical impact. Humanity has always believed in absolute truths, universal constants, and unshakable laws. If these are local rather than global, then certainty itself is a human illusion. Knowledge is provisional, perception is limited, and even mathematics, our supposed language of the cosmos, might only be a tool for interacting with a specific slice of reality. Science may not fail. It may simply be a beginner's guide to a universe far more complex than we can imagine. Our sense of mastery over the cosmos is challenged at its core. Now imagine the possibilities. A post-scientific civilization might learn to harness realities beyond human comprehension. They could communicate across dimensions, store consciousness in exotic states, manipulate dark energy, or encode life in the very structure of space-time. Our limitations would not exist for them. While we are bound by mortality, radiation, and matter, they might live as patterns of energy, distributed across systems, surviving and evolving indefinitely. The rules of life, death, space, and time could be entirely negotiable in their universe. And here comes the tease. The end of human physics is not a disaster, it is an invitation. It is the realization that science is not a final destination, but a starting point. Every unexplained phenomenon, every anomaly, every UFO, every cosmic puzzle may be evidence of layers of reality we have not yet learned to perceive. The universe is not constrained by our equations. It is far grander, stranger, and more malleable than we can measure. And the ultimate question remains: if we are only beginning to understand a fraction of reality, what lies beyond, and can humanity ever reach the level where physics is no longer a limitation but a tool, a medium, a canvas for existence itself? Exotic energy sources beyond nuclear fusion. We think we understand energy. We burn coal, split atoms, and even attempt nuclear fusion. These are monumental achievements, yet they are only a tiny fraction of what the universe has to offer. What if civilizations far older than ours have discovered ways to access energy that we cannot even imagine, sources that make fusion look primitive? We are talking about tapping into exotic energies that flow through spacetime, quantum fields, and dimensions beyond our perception. Here comes the shock. Nuclear fusion is still bound by matter, temperature, and gravity. It requires extreme conditions to release energy, and even then, containment is a major challenge. But what if advanced beings have learned to draw power from dark energy, vacuum fluctuations, zero-point energy, or even the gravitational interactions of entire star systems? Imagine a civilization whose energy budget is effectively limitless, unconstrained by fuel, distance, or decay. For them, energy scarcity does not exist. Power is as abundant as space itself. They might bend the universe to extract energy directly from the fabric of reality, rather than relying on chemical reactions or fission. Let us validate with what we know. Quantum field theory suggests that even empty space is not truly empty. There are fluctuations, virtual particles popping in and out of existence, and zero-point energy that hums quietly in the vacuum. We can measure tiny effects, like the Casimir effect, that hint at enormous reservoirs of energy lurking unseen. On Earth, we have only begun to tap into these subtle phenomena, and even then, only at microscopic scales. If a civilization can engineer materials, fields, or processes to harness these energies at macroscopic or stellar scales, the implications are staggering. Energy is no longer something you produce. It is something you channel from the universe itself. Now imagine the implications for technology. Space travel could become instantaneous. powered by energy drawn from the vacuum. Planetary systems could be stabilized or modified, drawing energy from gravitational tides or dark energy flows. Megastructures could be built without ever worrying about fuel. Entire civilizations could exist in isolated regions of space, sustained entirely by these exotic sources. The physics of power as we know it would be irrelevant. Efficiency, scarcity, and decay would no longer impose limits. And here is where it gets even stranger. Such energy sources might allow control over phenomena that we consider immutable. Gravity could be altered locally, time could be manipulated, matter could be rearranged at will. Weapons and defenses would become unimaginably advanced as energy constraints vanish. Communication across light years could occur instantaneously if energy is available to manipulate quantum fields. Civilization itself could accelerate in ways that seem impossible because the ultimate limiting factor, energy, would have ceased to be a limitation. Consider the philosophical implications. Humans have always struggled with energy scarcity. Wars, inequality, and even the survival of civilizations are often tied to access to power. A species that can harness exotic energy sources experiences reality differently. They do not need to conserve ration or compete for energy. Their challenges are not about survival, but about creativity, exploration, and understanding. Energy abundance transforms not just technology, but thought, society, and culture. For them, the universe is not a resource to be consumed. It is a medium to manipulate. Think about the environmental and societal impact. Humans strain the planet to extract fuel and minerals, creating conflicts and crises. A civilization with exotic energy sources would experience no such constraints. Planets could be preserved, ecosystems could thrive, and entire regions of space could be transformed without ever depleting resources. Energy scarcity would be a concept as alien to them as fire is to a fish. Civilization would advance not by struggle, but by imagination. Now comes the tease. If such energy sources exist, could we already be witnessing their effects without recognizing them? Cosmic phenomena like pulsars, gamma-ray bursts, or strange gravitational anomalies might not be natural at all. They could be the byproducts of civilizations, channeling energy on scales we cannot yet comprehend. UFOs might draw on power that allows sudden acceleration, invisibility, or incredible endurance, all impossible if limited to chemical or nuclear energy. The traces of advanced physics may be hiding in plain sight, visible only to those who understand the exotic sources that fuel them. Finally, consider the ultimate implication. If civilizations can harness energy beyond fusion, then our concept of limits, scarcity, and survival is incomplete. The universe itself becomes a medium for creation rather than a constraint. For humanity, this suggests that our energy struggles are temporary, and the next stages of civilization might operate on principles so alien that even our wildest imagination falls short. The ultimate frontier is not space or time, but the fundamental energies that permeate reality. And learning to access them could redefine everything we understand about life, civilization, and the cosmos itself. Could aliens master antimatter economies? When we hear the word antimatter, it sounds like science fiction, like something ripped out of a futuristic novel or a special effect in a movie. Yet antimatter is real. It is the mirror image of matter, with particles that annihilate their counterparts in a burst of pure energy. On Earth, we can only create tiny amounts in particle accelerators, and it costs astronomical sums to produce and store even a fraction of a gram. But what if advanced alien civilizations have cracked the code? What if they have built entire economies, technologies, and civilizations around antimatter? Here comes the shock. Antimatter is the most energy-dense substance known to science. 1 gram of antimatter annihilating with matter produces as much energy as a nuclear bomb. A few kilograms could power entire cities. A few tons could drive a starship across galaxies. If aliens can produce, store, and manipulate antimatter safely, they essentially possess limitless energy, compact and efficient. For them, antimatter could be what coal and oil once were for us, only infinitely more powerful. Their economic systems, their wars, their entire societal growth could be built around this ultimate energy currency. Let's validate this with what we already know. On Earth, antimatter is incredibly difficult to handle. As soon as it touches matter, it annihilates. Storing it requires magnetic traps, vacuum chambers, and precision that stretches our current technology to its limits. We produce nanograms at staggering costs, far more expensive than gold or diamonds. But these challenges are technological, not fundamental. Physics does not forbid antimatter economies. It only requires mastery of storage, production, and control. If aliens have developed materials or fields that can confine antimatter safely, then what seems impossible to us might be routine for them. Now imagine the implications. Energy is the foundation of every economy. On Earth, our entire history, our wars, our industries, our societies have been shaped by the struggle to control energy sources. Imagine if an alien civilization removed this struggle entirely by mastering antimatter. Every spacecraft, every city, every invention could have a power source smaller than a grain of sand, yet capable of sustaining it for years. Travel across space would not require slow, fuel-burning rockets. It would be instantaneous acceleration powered by bursts of antimatter annihilation. Their scale of expansion would dwarf ours because their energy was never scarce. And here is where it gets even stranger. An antimatter economy would not only power ships and cities, it would transform social structures. Energy would no longer be the limiting factor. Scarcity might vanish. Money itself could be tied to units of annihilation potential. Entire trade networks could revolve around exchanging controlled antimatter, not as a dangerous weapon, but as the ultimate resource. For us, energy economies shape nations and geopolitics. For them, antimatter could shape interstellar politics, trade agreements, and even the rise and fall of civilizations. Consider the risks. An antimatter economy is not just abundant, it is volatile. A single mistake could unleash catastrophic destruction. Entire planets could be obliterated by mishandled antimatter stockpiles. Yet for an advanced species, risk management could be part of daily life. They might have developed shielding technologies, energy fields, or storage methods that make antimatter safer than the gasoline in your car. To them, it is not terrifying. It is simply the medium of progress. And think about weapons. If energy equals power, then antimatter is the ultimate weapon. Beings that can harness it not only power civilizations, but could obliterate enemies instantly. Wars fought with antimatter would be incomprehensible to us, leaving nothing behind but radiation and silence. For that reason, a civilization that truly masters antimatter might quickly realize that war itself is self-destructive, pushing them toward cooperation, diplomacy, or expansion beyond violence. Antimatter might be so powerful that it forces peace, because conflict becomes mutually assured extinction at a cosmic scale. Now comes the tease. If aliens have built economies around antimatter, we might already see traces of it without realizing. Strange bursts of high-energy radiation, unexplained cosmic phenomena, or even the propulsion of UFOs could be byproducts of antimatter usage. What looks like a star flicker or an anomalous energy burst might actually be the exhaust of a civilization harnessing antimatter as casually as we burn coal. The evidence may already be in the skies. It just requires the perspective to interpret it. Finally, the ultimate implication. Mastering antimatter is not just about energy. It is about rewriting the structure of civilization itself. It removes scarcity, transforms economics, reshapes politics, and accelerates technology beyond anything humans can imagine. If aliens live in antimatter economies, then we are not just behind technologically. We are still at the very bottom of the cosmic ladder. The question is not whether antimatter can sustain life and society, but whether humanity will ever reach the point where energy abundance, risk mastery, and physics itself become the building blocks of our economy. And if aliens have already achieved this, then they are playing with the very building blocks of the universe as currency, while we are still burning fuel to move cars down the road. The shape of space non-Euclidean alien geometries, we grow up thinking of space as flat, endless, and predictable. Draw a line and it goes on forever. Two parallel lines never meet. Angles in a triangle always add up to 180 degrees. That is the world of Euclidean geometry, the geometry of classrooms and textbooks. But what if the universe does not play by those rules? What if space itself bends, twists, folds, and behaves in ways that defy everything we think is normal? And what if aliens are not only aware of this, but have learned to use non-Euclidean geometries as naturally as we use a map? Here is the shock. When Einstein introduced general relativity, he revealed that space is not flat at all. It is curved by mass and energy. Black holes bend space so severely that light itself cannot escape. Gravitational lensing bends entire galaxies like glass. The very expansion of the universe is geometry unfolding. So the shape of space is not a fixed grid. It is alive, dynamic, and mutable. Now imagine an alien species that perceives this directly, not as abstract math, but as part of their lived reality. To them, walking across curved space or building technology that rides its folds might be as simple as laying a road for us. Let us validate this with what we already know. Non-Euclidean geometry is not just an abstract theory. It is already embedded in our physics. We use it to calculate the orbits of planets, to understand GPS satellites, to model the structure of the universe itself. But our relationship to it is limited. We can only grasp it through equations, diagrams, and simulations. An alien species might have a brain structured to process curved geometries intuitively. What looks incomprehensible to us might feel as natural to them as breathing. Imagine perceiving 4 or 5 dimensions directly, seeing curves in space the way we see colors. Now think about the implications for technology. If you understand and manipulate non-Euclidean geometries, you could create shortcuts through space. You could design habitats that bend dimensions inward, fitting entire cities inside a volume no larger than a football field. You could create illusions of distance and proximity where two locations separated by light years are geometrically adjacent. For us, distance is a wall. For them, distance might be an illusion. And here is where it gets even stranger. Non-Euclidean structures could form the foundation of alien architecture and society. Imagine buildings that fold space inside themselves, with endless rooms hidden in a structure that looks tiny from the outside, or ships that vanish by slipping sideways into geometries we cannot perceive. To us, this would look like magic, disappearing craft, impossible structures, sudden travel across the stars. But for them, it would be simple engineering, guided by geometry that bends rather than obeys straight lines. Think about how this changes perception. Humans navigate by recognizing straight paths, familiar distances, and measurable scales. Our maps are built on flat approximations, but an alien species immersed in curved space would not see the world that way. Their maps might look like swirling fields of curves and knots. Their sense of direction might be completely unintelligible to us. A journey that feels impossible in our framework could feel effortless in theirs, simply because they perceive geometry differently. And there is a psychological dimension too. We think of reality as stable because we assume space is fixed. But a civilization that sees space bending and shifting would not think of the universe as permanent. They would see it as fluid, malleable, subject to design. Their philosophy, their sense of self, even their definition of existence would be tied to geometry that moves. They might not fear distance, death, or confinement the way we do, because space, to them, is always negotiable. Now comes the tease. If aliens already use non-Euclidean geometries, could we already be witnessing hints of it without realizing? UFOs that shift direction instantly or seem larger on the inside than on the outside might not be using propulsion at all. They could be bending the space around them, slipping through geometric folds invisible to us. Even some anomalies in physics, dark matter effects, unexplained gravitational distortions, might not be mysterious particles, but the fingerprints of civilizations bending the geometry of reality itself. And here is the ultimate implication. For humans, Euclidean geometry is the baseline of how we understand the world. But if aliens live in non-Euclidean space, then their entire worldview, their science, their art, their technology, and their society rest on a foundation we can barely glimpse. To them, the universe is not a box with fixed rules. It is a canvas of curves, folds, and hidden passages waiting to be shaped. For us, geometry is a subject in school. For them, it is the key to the stars.